Hello, X2. Okay. Good morning, everyone. Hey, thank you some coffee. Thank you. It'll have to be tea, not coffee. But yeah, thanks. Thank you, thank you, thank you. So we're doing Opus Dread today. This is gonna be interesting. Yesterday I spent like an hour off stream working on packaging Opus for Zig. We already had a package. Okay, so let me tell you the full story of this package. So I packaged Opus for Zig a long time ago. I did not do a super thorough job. I just got it working. There's, for example, a bunch of architecture specific files that I haven't wired in. So I wouldn't call the package that I have on that I made on all your code base the best package ever. It's definitely not. But in any case, it was already there, and then I just did the changes to add support for uh, um, yeah, for this guy. And man, it took a while to get there. It took about an hour, but I got it. I got it building. Now, did I get it working? That is a much bigger question. And the answer is I don't know. I'm actually going in blind because um, I'm going in blind because I don't have anything to test it with. And to test it, I actually need to do the integration work, which is non-trivial. So that's what we're gonna do today. Mm-mm-mm. Yeah. So, what else actually? I mean, that this is my main concern right now. Also, I titled the thing Dread. There's no A, it's just Dread with the with an E, but never mind. That was a Freudian slip. Uh, okay, so um, I'm actually thinking of swapping these two around and do a little bit of chores first. So, for example, I think this encoder should become a struct. Actually, can't be a struct. Well, it would have to be a struct that wraps the original encoder because we cannot make an opaque for it. Hmm. 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 What is an opaque? So when you interact with C APIs, you oftentimes have stuff like this one. Is that like an opaque pointer? Yes. So in C you have void star, right? And everything is void star. So you have void star this, you have void star that. I guess sometimes this can be there can be made aliases for void star. But even if you type def it, it's still it's still a quantity that you pass around, um, essentially untyped. In Zig, void star C void star in Zig is star any opaque. But any opaque is essentially a type erased opaque. So non-type erased opaques are um, pointers. Well, encoder is not exactly a pointer, but you can only move them around as pointers. Like I can return a pointer to an encoder, but I cannot return an encoder because the idea is that this is a as a struct. We don't know this how big it is. We just know that we can refer to it as a pointer, which is the reality of how these things often work. And but the advantage is that first of all, these are like hard types. So instead of designing your APIs that accept, you can make function foo that accepts void star. Well, let's say that C has a function called foo that returns a void star and accepts void star, void star. Yeah, good fucking luck getting this right. I mean, maybe it depends. Some are harder, some are easier, but it's easy to get confused. So when you write a wrapper for this function, or when you write an extern, you can an extern would be the Zig side definition of this of a C function. The extern could be that the function is foo. It accepts a encoder. Sorry, it accepts a pointer to encoder, a pointer to another encoder. I don't know, and returns a decoder. That doesn't make a lot of sense in the context of Opus. But the point is that you can basically give proper types to void star things from C, and they have a body. So in the body, you can define functions. So you can give them methods. So basically, instead of only having the naked C function that accepts these things as parameters or returns them, you can give them nice APIs that allow you to do stuff like, decoder dot, and then autocomplete will give you the things that you can do on it. It's a strongly typed alias of a void pointer that you can give methods to. In from the C side, if you write the extern wrong, so for example, let's say that the original function accepted expected to encoders, but you got this wrong, and you say that this is a decoder, then your type def is wrong, and your stuff will not work correctly, and there is no type checking possible. But uh, but on the Zig side, so once if you get the external definition right on the Zig side, then these guys are strongly typed, and you're not gonna be able to misplace them. If something wants an encoder, you have to give it an encoder. If instead you define this as an any opaque, which is the exact equivalent, this is the closest equivalent to a void star, then now you can pass pretty much whatever you want. Any pointer is fine here, essentially. Well, I think Zig will still want to ask you to um, pointer cast, I believe. At least in some circumstances, it will ask you to pointer cast. But everything is, it's much easier to get this stuff wrong like this. So opaques allow you to represent um, essentially resources that you refer to by pointer. That being said, I've been doing this because I've been using the Opus encoder create functions. So I guess I'll do a quick explanation of what I was doing here. Opus gives you a function to heap allocate a decoder and grab and obtain and same with an encoder, sorry, and obtain a pointer to it. Now this works, but it is inefficient because while we heap allocating a struct that we could not heap allocate? Well, the answer is that Opus gives you these as a convenience because they kind of have to, in the sense that it happens very often. The people do dynamic linking against libraries, including Opus. So if you're writing a program that does dynamic linking, you don't know which version of Opus you're going to get. You're going to get whatever the system happens to have available at that time. And different versions of Opus will have the struct have different sizes potentially. So by delegating this work to a function, the function stays stable. The struct might change size, but then you refer to it only by pointer, and all you do is give it back to Opus functions, which will be always in sync with the concrete implementation because they all come from the same DLL. So everything will be fine. But here's the catch: we're not doing dynamic linking. We're doing absolutely static linking of Opus, and we don't care about the dynamic linking use case. So, long story short, my wrapper used the wrong approach. My wrapper used the wrong approach, and so we need to change strategy. We need to go from a wrapper of opaque pointers. We need to go to a struct wrapper. So pub const encoder needs to be a struct that contains the original, let's call it raw data structure, which is going to be a opus h dot opus h dot opus struct opus encoder. They don't even type def it. Interesting. There you go. That's the struct. Opaque? No, you're joking. No, it is not opaque. Is it really opaque? No, 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 no. This header file needs to be regenerated. No, 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 no. Wait a second. Opus types. What do we have in here? I don't think this will have struct definitions. I would assume these are just the numeric types, essentially. Yeah. Opus.h. There might be a flag behind those struct definitions. Holy shit. Yeah, so struct opus encoder, type def as opus encoder. Awesome. But that struct comes from, opus.c, I guess. Now I'm confused how I'm going to get to the actual struct implementation. Hmm. Okay, let's do this. Let's go in include. Let's go in opus. Let's look at this. This is the definition, yes. Um, yes. So this type def is defined in here. You're a very smart boy. GitHub, yes. But where's the struct defined? Wait, it cannot just be left empty no matter what. I don't believe it. I don't believe it for a second. So where is this guy defined? There we go. Oh, opus encoder.c. So this guy has the definition. Okay, let me think about it for a second. The problem is that I you know what? I think it might really be the case that they don't really want you to do they don't normally expect you to inline these structs anywhere. They expect you to heap allocate them. Huh. Hmm. How would you solve this in C? Do you just C import this file? Yeah, I guess that would be it, right? The problem is that this has some dependencies on macros that I've defined. Okay, so for this to work out, we need um translate C to be fully integrated. And right now we are opting out of this. So you know what? This goes away. We don't do this. So let's switch to the other main task. This is too early. Can't do it. Okay. So um, here I have a flag that enables dread. One is set to 100. So now, as things stand with this current configuration, we are producing dread data. And if we look at if we start a client, after it's done building an endless amount of stuff, there we go. Test, test. So yeah, it still works because Dread is an extension that we're currently not using. Essentially, we are adding a bunch of wasteful data to our packets that is just not being used. So, um, well, so far so good. We haven't broken everything horribly, so we survived the initial test. Then the next thing that we want to look at is well, we need to start making use of Dread. So, whew, jitter buffer. Okay. Now, when we write a packet, we need to process it. So our packet ring, you just write restart sequence and data. But now this playback packet ring needs to have more weird stuff added to it. So we have meta with sequence and restart. We have data with the data, and then we need to have Dread. We need to have Dread with what? Basically, we need to call, we want to write in here dread.parse. So we need a Dread state in here. So let me go take a look at the API. I was actually right. Let's read some more. We have these opus get Dread size. Ah, man. It's okay. Okay, so let's see. Allocates and initializes a Dread state. Freeze a Dread allocated by opus that I create. Decode an opus Dread packet. And so you give to it a Dread state. And then you call Dread process. And there's a source and a destination. To store the updated state after processing. Hmm. So what we could do is this. We receive a packet. If we know that we're missing a number, if the sequence number is not the right next one, then what we do is uh we parse the Dread stuff. Otherwise, we know that we're not gonna use it. So we only do the Dread stuff if if the previous packet is missing. Yes. And then we update to the current packet. Although we need to be precise with how we word this. In any case, here there's going to be dread stuff. We don't know yet where it's going to be in there, but we're going to have to put it there. In here, not in here, but in up here. In right packet. In right packet, we have this information available to us in here. And it is funny. As we compute stats, so this is the new restart. And this is the delta. I'll disable stats for a moment. They're cool, but not too interesting. Hmm. No, you know what? Okay, it's fine. We put the dread stuff in the middle, I guess. Also, why do we think that this is a comment? So stats restart. Um, I got two questions. Any book recommendations for a newcomer? By the way, you know that you can just use Twitch if you wanna message. Anyway, any book recommendations for a newcomer to systems programming? Will Awebo have beginner-friendly issues? I'll start from the second. Eventually, yes. Right now, not much. But as we go forward, there will be issues where you don't even have to do anything particularly crazy with Zig. All you have to do is I don't know, polish how certain stuff looks visually, um, polish a little bit certain workflows. So some things will not require a lot of Zig knowledge. Right now, they tend to be more. Right now, if you are a beginner, Weibo is not exactly too friendly to newcomers, or rather, yeah, beginners. Beginner, sorry, I should say beginner, not newcomer. Okay, any book recommendations for a newcomer to systems programming? Oof. Uh, I frankly don't have any. I don't think. I do think that they might exist, uh, but I personally do not know any that I would recommend. Um, Understandably, you might want you might want to see a comprehensive thing that teaches you all the things that you don't know, right? So, um, I guess if you are into this kind of book, one thing that you could try is find a book that teaches you about, uh, you know, um, like computers and networking. There's I forget the name of the class, but university has a class on that subject where they teach you about network protocols and how your computer works, virtual memory, file systems, CPU architecture. So those things are useful things to know, generally speaking. So if you don't know anything, like if you have no idea at all about what virtual memory is and how it works, then those books can help. And they will give you a general, you know, um, they'll sprinkle knowledge that is generally useful in your head. That being said, they wouldn't, in my experience, they will not give you, they will not go into any specific subject um, consistently enough or like in a updated enough way, because they at least the books that I remember, they were already talking about old stuff like 15 years ago when I was in university. So now it's even worse probably. So they will not give you, like, they will not get you to a point where, okay, now I sit down and I now understand what my first step has to be to implement, for example, um ls, but you do it for ls as in, the terminal command, but implemented by yourself. So my a better recommendation that I have is to join a Z community. So there's a list of communities on the Zig website. Join some online Zig communities. I would suggest to try more than one. You might not like all of them. Like, Zig communities are all very different and they're all um, managed by different people. Some will definitely be more of your interest than others. And then, if you have the ability to do so, go to zig.day, or rather, well, go to zig.day. You can go to the website. But if you have the ability, like if you happen to have a Zig day near you, try to attend a Zig day. That is also um, very nice. So, um, long story short, as things stand, in my opinion, you are better off learning systems programming by doing rather than by reading. Um, that is a universal truth to some degree. To some degree, to learn systems programming, you have to do systems programming. But with, with the right teaching materials, you could probably get some kind of like head start, like hit the ground running a little bit better if you had a good book that prepared you for, to give you some initial momentum. Um, Unfortunately, I don't know of any. And the ones that I do know about, I don't know any that I would recommend. The ones that I do know about, which to be clear, I don't even remember the titles. It's just stuff that I happen to read, see in the past, like scroll past, that kind of stuff. One problem they have is that they really love conflating systems programming with C specific stuff. Like, I remember this book that would go into super detail into the C compilation model, because the C compilation model is, I don't know, like super critical to understanding how your computer works. And that's not exactly true. So, personally, what I would like from a book of that kind is that it taught me the timeless stuff, understanding that it's more timeless. Like, I mean, nothing is entirely timeless, right? But we can agree that, function calls, stack versus heap, virtual memory, these are more timeless than the way C solves macros, for example. So I would like that it clearly define those things as the more important ones, and then there would be separate chapters, ideally a separate book that got into the C specific stuff. To be fair, though, it is true that C is kind of a special programming language in that sense, and eventually you will want to learn its compilation model. Well, because, for example, here I'm using Opus, which is the audio codec for real-time audio, and it's written in C. And to be able to package it correctly and enable the new stuff, I need to know how you compile C code, how you set macros, how that creates a config header, how then you define a macro that says, yes, we do have a config header. Go grab those settings from the config header, instead of expecting them to be all provided from the CLI. Then you need to figure out which C files to include and which to exclude, because there's some C files in there that if you add it to the compilation, they will fail your compilation, and so they should not be included, and etc. 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 So you need all to learn all this stuff eventually. But I I would not consider knowing how C works a prerequisite for systems programming. And I think that you should learn C as you go. Like you should learn enough of C that you need to fulfill your next task. So, um, uh, what Eternal Keyboard has one good suggestion: do make projects. Nothing. Start with stuff that is not ambitious. You cannot start with something super ambitious. Like I'll make a music player from scratch, dude. You won't. It's super fucking complicated, and you will die. You will just die if you attempt that first thing. If you know nothing, so start with something not ambitious. Get your wet feet, and then increase complexity a bit at a time. Um, and eventually you will be able to make music players and even more complicated stuff. Music players, like in the grand scale of things, are complicated, but they're not impossibly complicated. Nowhere near, not even remotely. So you can get there. You just need to work your way up there incrementally. It's like I don't know, lifting 100 kilos in deadlift. It's like you can do it, but that cannot be your first lift. Like you don't need to be special to be able to do that. It just cannot be your first lift if you've never done deadlift before. That's it, yeah. And but as I was saying, communities help a lot. I would argue that communities, like I would argue, here's my argument. I would argue that books are convenient without a doubt, but they are a surrogate for having around you people that know things. If you have people around you that know things, and you're not obnoxious, and you know how to search chat history so that you don't ask forever the same basic question, and then you just do the super basic stuff yourself by looking at chat history, and then you fine tune your request to the specifics of your case. Then um, having live people that can observe your question and answer it, it's better than having a book. So if you're alone and you don't have anybody, obviously a book is better than nothing. But in my opinion, people are better. You can make the same argument for AI. AI is good, worse than books in some ways, because the book doesn't usually lie as much as AIs do. Although it still does. They still might. But an AI is nice because it can answer queries. Like a book can only present you information in a static manner, and it's up to you to learn how to map your question to how the book presents the information. AI does that for you, but it's still not as good as a real human. So, um, I, a book a book and AI are surrogates for having other human beings. So far today, human beings tend to be, the best package for knowledge. They can be as precise as books. They can be as interactive as AIs, and they can give you a great experience. So, yeah. Now, even for learning, they're still a surrogate. Like, sure, they're great. They are complementary to books. In some ways, they're better. They're still not as good as humans, though. Okay, so like you're learning Zig. Okay, you're learning in Zig, and you're at a Zig day. So Zig days. So just for context, Zig days is what I was talking about when I went here to Zig.day. These are like in-person events where you do collaborative programming. So um these are some photos from a past event to give you an idea. This is how it looked like. There's this one. This one had Andrew in it, I think. Um, no, this one did not. It's the third one that did have Andrew in it, right? Yeah. So okay, imagine that you're at a Zig day, okay, and imagine that you're this guy, for example, the guy here with the glasses, and you have a question about Zig. Option A, you open a book and try to find in the book the answer. Option B, you ask Claude to give you the answer. Option C, you turn on the side to the side and you ask Andrew. Which one do you think is the best option? Let's assume that the question is not, super trivial. You have a question that is not immediately answered by the language reference. Human, yeah. By the way, in particular in this case, this human, this is the guy that made the language. So obviously Andrew is the better choice, right? So that there is no discussion there. Humans still today, I don't know, might not be true in the future, but today still, if you have a question about Zig, the best guy to ask this question to is Andrew. If you have him sitting next to you, if you don't have Andrew sitting next to you, then maybe ask ChatGPT. I don't know. Well, I mean, if you have somebody else, like if you're at a Zig day and you have somebody else sitting next to you, maybe I would still see if the human happens to know that. But yeah, not everyone can access the creator of language. Absolutely, that's the point of being a surrogate, right? AI is a surrogate for a human being, just like a book is a surrogate for a human being. Again, I don't know. You're studying fucking physics. Would you prefer? And you have a question about physics. Are you gonna ask? Are you gonna try to open a book and see the answer in the book? Or if you have, I don't know, fucking Einstein sitting next to you, you're gonna ask Einstein. Of course, you're gonna ask Einstein. Obviously, you don't always have the best possible available human being for a given subject sitting next to you, but still, the point is that is that ultimately the best choice possible is always a human being, which is why it makes these other things surrogates so far. Probably for a long while more. Anyway, so if you go to a Zig day, you will probably not have the creator of the language sitting next to you unless you go to the one in Portland. But you will still have other people that are into Zig that will be able to help you. And in a sense, online communities are similar. Online communities will have people that know Zig and they will be able to help you. Okay. So we need to do packet writing. Yeah. Yeah, but in any case, I mean, I'm bringing up Andrew just to make a very clear cut example. In a sense, it's an hyperbole. I'm taking that to an extreme. Um, but you will find people that, like, I would argue that the average quality of advice that you get from Discord, from Zig Discord communities, like from Zig communities, is superior to the quality of the advice that you get from Claude. And today, the same is true also when it comes to books. There are a couple Zig books that exist, and I think they're fine. Yeah, well, I mean, let's set aside the AI slop ones. There are some AI slop. They're clear scams. They don't count. But like of the real books that have been written about Zig, they're fine. But I would still argue that the average quality of the advice that you get in Discord is better, and it is better also what you get from Opus, Cloud Opus or whatever. So yeah, hello. Okay, um, so it's a restart. On restart, just write the packet and never process thread. We're starting from silence, and there's no missing data. Well, it cannot be. Well, that is the. But again, it's an hyperbole, but it does, in my opinion, if you think about it from a mathematical proof perspective, it's the mathematical proof that AI is a surrogate. It's a surrogate for human beings. It's not superior. The day that asking an AI is preferable will lead you to better outcomes than asking the language creator, then holy shit, things will have changed. But that's not the case today. Now, from a practical perspective, there is one thing that is true. Andrew is a limited resource. He's not everywhere all at once. Can only answer one question at a time, more or less, give or take. He has about, I guess, 8 hours of downtime every day. These AI bots have less than that. I mean, they still have fucking downtime. We've seen these multiple times. They're not on 24/7. That's for fucking sure. But they have shorter downtimes. That's for sure. Have you ever asked Bjorn something? Oh man, no, I haven't. I work with C# and .NET professionally, but have been wanting to learn lower level concepts and programming for a while, which is how I came across Zig. Nice. Yes. If that is what you're interested in, you're in for the journey of a lifetime. I have done C# in the past, thankfully for a relatively short amount of time, and I did learn a lot of things, good things. I also seen a lot more things that I hope to never have to see ever again. C# is culturally an ecosystem. So I'm not talking about, libraries that you can download from NuGet or, language features. I'm talking about like the culture around C# and .NET. Culturally, you exist in a um, alternative programming universe where all that matters is object-oriented programming, clean code, the hexagonal architecture, microservices, event sourcing, DDD, as in domain-driven design. And sure, some of this stuff is meaningful, and it does have a place in the kind of development that you tend normally to do with C#, .NET, consultancy, enterprise software development, that kind of stuff. But boy, that is not all that there is to it when it comes to programming. There is so much more that is completely ignored in those cultural circles. So getting your head out of that is good for the soul. It's good for the soul. That's for sure. So you did not start with systems programming, right? How did you get to where you are now? Yes, I did not start with systems programming. Technically, I studied bioinformatics. The way I got to where I'm now is that I was working for a consultancy company and doing consultancy for a fintech startup where I ended up implementing a probabilistic data structure as a Redis module. So I wanted to add I needed to add the probabilistic data structure to Redis. And I learned that you could add modules that are to Redis that allowed you to, have these things really run inside of Redis. And so you could use them as keys and have your own custom commands. And so that had me do some C. I did some C to get that stuff working. Then I discovered Zig. Then I got hired at Redis Labs. Then I discovered Zig. Then I I was hired at Redis Labs as a developer advocate. I discovered Zig, and I used Zig to show people how to write Zig modules without having to freeing your being free while being free from some of the annoyances of C. Um, then I switched to the Zig Software Foundation, and I've been doing Zig since then. And bit by bit, you just learn how to do things. Again, you just start incrementally. And I can promise you that being like, my recommendation where I tell people become part of the community, like, this is seriously the best advice that I can give you. It might not sound like it, but it is by far the most effective. I could recommend you the best possible. Like, imagine that I can magically learn what is the best possible book about systems programming and recommend it to you. I would still consider that a way less effective piece of advice than telling you to join the Z community, interact with other people that are like on a similar journey than you, and just basically, enter the flow. You join a community, start working on simple projects, talk with other people about things that you get stuck on, help other people with things that they get stuck on that you already have figured out, and walk the walk. It's like getting to level 80 in World of Warcraft or something. I've never really played World of Warcraft, so I don't know. I said it, but I don't really have first-hand experience with that. But that's kind of how it works, right? I mean, you start with you do the grind to get to level 80, and then at that point you can do PvP, I believe, or at least you used to. So that's kind of the same with systems programming. Do a bit of grind, do it with other people so that you can progress faster, and then you will eventually start hitting a level where you can do PvP, where you can start tackling more serious projects from a systems programming perspective. If you want a well-packaged way of expressing some of these ideas, so instead of listening to me rant incoherently for an hour, you can listen to me rant more coherently for 35 minutes. Henry also has some good talks, although I would consider this one more of a starting point. Andrew has also nice talks that I would personally consider slightly more advanced. But search Andrew Kelly also on YouTube. You will find good talks for him. Yeah, slightly less incoherently. Okay, let's see. On restart, just write the packet never processed thread. We're starting from silence and there cannot be missing data. Yes. Then here, before we increase the sequence number, the question is, oh, this is interesting. So the packet that we receive, okay, you know what? We can even leave this increment happen early. That's fine. The question is, if JB stats the sequence is the same as our sequence, then everything is fine. But if it's not the same, if it's different, then we have to do things. But then here's the question. Is it lower or is it greater? So here what happened is that um, packet loss, essentially, let's say probable packet loss, because we skipped a sequence number, but the older packet might still be arriving. It might be late for whatever reason. So in that case, um, if it's not too late, it's not a real packet loss because it will still arrive on time and we're still going to use it. So it's going to be fine. So this is probable packet loss. And here it's packet arriving late. Okay, so the question is, in probable packet loss, what do we want to do? 100% we need to process thread. Process thread. Process thread unconditionally. We need to prepare. Maybe that packet will arrive. Maybe it won't. So now here's the problem. There's a packet arriving late. The fuck do we do with it? Now here's the thing. It's most probably a waste, but we kind of have to process thread for this guy because 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 so what might be happening is that we're in this situation. Missing arrived. So this might be the situation before this packet arrives. Our playhead is currently here. And we receive this packet. This is the packet that we just received. Oh, I wish I had the... I'm going to put an L. It is like this arrow coming down and then... oh, you know what? We can... this makes it better. So this is going to be... yeah, there we go. There was actually a more optimal solution without even having to think much. So this is going to be this packet. So if we are in this case, I'm going to say D. Oh, what did I do? So we might be in this situation. We have received previously this packet, which has a bunch of previously missing packets. So we did process thread unconditionally. Then this packet arrives, and the reality is that we will want to use this packet for thread. Maybe not. Unfortunately, actually, there is no way for us. This is unfortunate. Since we don't have a lot of memory, maybe this might have arrived, in which case there is no point in computing thread for this packet. If this was the case, this is a complete waste. We computed thread for a packet whose thread we're definitely not going to use. We could have remembered this. The problem is, well, right now we don't. We could do some bookkeeping for that. The reality is that we wouldn't even need to keep around uh, that many values because I mean, uh, I guess you want to remember buffer size, buffer capacity. You want to remember buffer capacity sequence numbers, I guess. I'm trying to evaluate how much do I want to not do useless uh, dread work. The thing is, if dread is not that hard, if dread is not that complicated, eh, why even bother? Hmm. Hmm. You know what? For a starting point, so here's what I'm gonna do. We also process thread unconditionally. That being said, okay, for simplicity, since we're not doing anything advanced, we can do this. If jb.states stats sequence is different than sequence, packet is uh, either packet loss or packets arriving out of order. Let's process thread unconditionally. Okay. So either packet loss or packets arriving out of order. Let's process data unconditionally. See comment block above for a possible optimization. Okay. So how do we do this? So now we need to do the parsing, the dread parsing. I think we need one dread parser. So in here we're gonna do I think it's called dread decoder. We don't have opus. Oh shit. This guy used to be such a beautiful self-contained data structure, and now it's not anymore. what an exchange. Okay, we have the dread decoder. Then now we need a dread state. The thing is, we need one dread state per packet. That part is kind of clear to me. We're gonna need a dread state per packet. Now, here's where things get funny because we were previously able to just do write and just give the data to uh, to our to our thing. But now we're gonna need begin write, because we need to reutilize the dread. We cannot keep heap allocating dreads forever. So yeah. Ring buffer of threads? Yes. Can you share your NeoBeam config? I can't. I don't use NeoBeam. I use flow control. Uh, Okay, packets need some refactoring. So we have the dread stuff, and that means that we need an init. So this guy cannot be just set to undefined. We can make these optional, but we might as well just pre-allocate these things all at once. By the way, is there no so there's opus dread get size. Oh man, this is so tempting. Okay, we're eventually gonna go down this path, but for now this is fine. So this is gonna be have a state. It's a pointer to Awebo opus dread state, and then there's gonna be info, right? Dread info. Okay, and that means that now we cannot just do empty anymore. Goodbye, empty. Be nice meeting you. We're gonna need pub function init, which takes in a GPA. How joyous. And returns a packet buffer, packet ring. Oh no, wait, we don't accept a GPA because we never mind, we need an init, but we don't accept a GPA because we're secretly malooking. Oh no. What are you gonna do? Playback packet ring. Okay. And this other guy can be undefined. Also, this is not a pointer. Red info is just a normal struct. Leave it undefined. Okay. Okay, so this initializes all the dreads. So we're gonna have dreads available to us. Now here's the problem. Are we getting spammed by a bot? Recto 2 Classic. What is going on here, man? Yeah, are you high? Oh my god. Okay. So this is gonna be, I'm gonna keep normal right. This is gonna be fine. And then we're gonna have right dread. The problem is gonna be this. This is gonna be commit right dread prompted. write red begin, which gives us a slot where to put the thread. And then we're going to do all the thread stuff to it. We pass back the thread. It's going to be something like this. Okay. This is essentially write thread commit. Yeah, and then there's going to be write thread begin. Okay. There are no arguments that we take in. We're going to return something different. We're going to return a pub const thread write. But we're going to copy over the pointers because we don't modify the pointers. We just modify the values. State is going to be opus dot awebo opus thread state. Info is going to be pointer to awebo opus thread info. And then there's going to be R and W. That kind of stuff. So write thread begin. If it is not full, we don't do any math in here. We don't store anything. All we do is return thread write. W U32 R U32. Actually, we do this to grab the thread stuff. We might not need R after all. We'll see. So you give me the thread write. We don't need to do this check anymore. We just need to do the assignments. Oh shit. Okay, so we grab the W that we were given. We meme copy all the data, blah, 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 blah. the dread stuff has been written to. Yeah, we don't need R. There you go. And with this, we should be happy. So now we can do write thread begin, write thread commit. This is going to be DW. And here we need to do the thread stuff. So what do we need to do? We need to do, we just use one decoder. So we do gb.threadcoder.parse dw.state data processing eager for now. This is going to be something that errors out. This returns red info or an error. Well, shit. That is bad. So dw.info equals this. Catch. Okay, in this case, what we want to do is this. With an info that tells us that we don't have anything in here, which I think we can do. Also, this is info.star equals. Now, what's in a info? Available and end. We can, if we got an error, then we say available is 0 and is 0. Okay, that's nice. Holy shit, I think we integrated it. Okay, so the jitter side is fully integrated. That was it. Now the only the only part that remains is in the audio callback when we find when we find a missing packet, then we need to start looking into the thread data. And actually, oh shit. Judge thread, yeah. Yeah. Your sentence, packet lost. We need to change next packet. Next packet needs to tell us. Oh man, next packet returns. So it returns when starting, we should play silence. So it returns starting. And then playing. If payload is null, it means that the packet was lost. But now we can't do this anymore. Now it has to be packet lost, I think we need different cases, right? Like playing cannot be present or missing. It has to be present, missing, um and the dread. Why the BLK? As a Zig programmer, I am curious. Why do you need why do you feel the need to specify as a Zig programmer? Like that part confuses me. Actually, as a Zig programmer, you should know what this is. If you're not a Zig programmer, then it makes sense that you don't know what this label here does. But if you are a Zig programmer, then you should know. So basically, we are assigning a value. We're writing to a pointer, but setting aside the detail, we're assigning a value to this field. So if the parse succeeds, then it will have produced a value to put there. It will have produced a thread info. I'm gonna put a training comma here. Um, so it will have produced a thread info, which we end up writing in here. But if there's an error, it will have on an error, it will have produced something that is, well, it would not have produced a thread info. So we need to supply one. And so this is where the labeled block comes in. On an error, we point out that we had trouble parsing the thread data, and we supply a alternative value that will end up being written down there. Because in C, this wouldn't be the usual. Then if you say as a C programmer, you're curious, that also would make sense to me. Also, not only would not be usual, it would not be possible. You don't have labeled blocks with the ability to break from them with a value in C. So okay, what is going on in this chat? I don't get this. Okay, so here's what I'm gonna do. Let's bring some normality to this chat. Retro to classic, you're gone. I don't know what the fuck is up with you. Goodbye. Jesus. The good thing is that you can still ban people and they can at least watch the stream if they want. But like I don't know why people are coming here making chat weird. Okay, dread begin, dread commit. So this part is good. We were saying now when we return the next value, we need to be more careful about it because it might be either the current, it might be missing current, or um or dread. So let's do it this way. There will be a separate function for this. Um, you could do it, but in that case, it's very convenient to just have a tiny block because we're essentially briefly hijacking flow control just to print out a message that we encountered an error. And yeah, you are right in saying that there is some overlap, a lot of overlap between having a block that breaks with a value and having a function. But in this case, we can agree that having a function that all it does is print this error and then return this, it's kind of silly, right? Function, I don't know, dread error. Awebo.opus.threadinfo log.debug error blah blah, right? So I'm doing a simplified version. Error t r return I mean, you could do this. So you could do, um, you could essentially do this then. dw.info, and then you do catch error, red error, and then the value of this function goes in here. Just to do this. Eh. There is an argument to be made, though, that sometimes you might be tempted to put way too much stuff in a block, and it would be better off as a separate function. Um, that is a mistake that one can make, for sure. So starting, Playing has a R value and a data, right? Um, Contains data, must contain R, and it must contain also dread. Hmm. Hello, Diablo. Hello, Temporus. I'm fine. I'm just in the middle of refactoring code to add the dread support, which is pretty cool. I'm not yet at a point where I can demo this, but I can. You know what? Maybe I can find an online demo of dread. Let's see. Let me put it this way. I'm still sad from the horrible experience with Apple's AV audio engine. God damn it, man. That thing really took the wind out of my sails. I was cruising before getting stuck in that bog of an API. I was cruising with Awebo. But you know what? I'm kind of back to cruising. So this is going to be a good improvement. Yeah, but I feel like that API. By the way, you know what? This is when I gave up. Okay, this is the exact moment where you could see my heart break, and I decided to give up. Um, it so what was happening is that when restarting the engine, it would sometimes fail, and then I would notice that I had a print that showed me the format configuration that the engine was using for a given device. And I noticed that sometimes these values made absolutely no fucking sense whatsoever. And then so for example, I turn on when I turn on the webcam audio and it works, you see that the hardware format is single channel 24 kilohertz. Fine. Then actually no, 16 kilohertz. The webcam microphone is really shit. So 16 kilohertz. single channel. Then I move things around trigger another device change and another engine restart, and the engine decides that the webcam is now 2 channel 48 kilohertz. Why? Impossible. Impossible to know. Um, then I look at and then I start looking at the core audio APIs for grabbing hardware configuration, not from the abstraction at the audio engine level, but below, like the lowest abstraction level that you have, which is core audio. And it always reports the right value. So like we have the hardware that gives you the right value, but the audio unit used by audio engine, which is the higher level abstraction, is convinced of a different value. With the engine stopped, I tried to use the format that the hardware was giving me with the audio engine, and I tripped an assertion saying that the audio unit has a format that doesn't match the format that I'm putting on the wire in the audio engine. So I go and find code to change the format in an audio unit, and I change the format in the audio unit to match what I get from the hardware. What I'm getting from the fucking hardware by querying it a second before, like right after, not even a second, way less than a second. Like the value that I get from querying it right after, right before. And I do it, and I trip a different assertion. So long story short, sometimes audio engine decides to use completely misunderstands what the format should be for certain devices, and there is no fix. There's just no fix, because you see that it's doing the wrong thing, and there's nothing you can do to stop it from doing the wrong thing. Try to search on the internet, no replies. AI, let's leave aside AI. AI doesn't understand shit of that stuff. Partially understandably, because there's not a lot of comment, a lot of information out there. And so, oh man, Jack on Linux has a bunch of user after freeze. Delightful. Pipewire the same. WhatsApp on Windows is exactly what you would expect. Yeah. Oh man. Yeah, the problem is that in this application, what I'm doing with the audio is kind of one of the core offerings of my application. So I don't want to offload this to SDL or any abstraction that is like too high level. Um, for example, another thing that I want to get out of this system is echo cancellation from speakers. I don't remember. I demoed this at some point while I was live. Uh, when it works, the echo cancellation from Apple is insanely good. I had it turned on, like it was so fucking good because I had it turned on with the what's it called? I had it turned on my laptop with speakers, and I could talk to the laptop, and the laptop would reflect my voice back at me from speakers without catching any of that from the microphone. It was spooky because my own voice was talking at me from another thing. Like I have a zero delay feedback turned on right now in my headphones. I can hear myself through my headphones. But it's how can I say? It only sounds like I have a stronger voice than I actually have. But having a different device do that to you with through speakers, it was kind of funny. Um, was it fast enough to not speech jam? It was very low delay it was surprisingly low delay. I think it was kind of there. Like it wasn't delayed enough to speech jam me, but it was a little bit too delayed to be comfortable. It was, in any case, it was just a demo, so it was like you wouldn't have that set up normally. There's no reason to have that set up normally, but it was so good, man. It was really so good. Yeah. So I want to leverage that. The problem is that the rest of the ecosystem is I don't know, weirdly broken. Fucking Apple. Let's see. Contains compressed Opus packet. Uh, Packet loss happened. This is a future packet that you should get dread data from. Let's call it dread samples from. And then there's missing. Packet is missing, and there is no dread, no future packet available for dread. Play silence. Play silence through Opus. I think this is gonna be the new interface of our jitter buffer towards the audio card callback. Although to be fair, these are like from the perspective of the audio card, whether we are starting or it's missing, it doesn't make any difference. So here's what I'm going to do. Although starting could mean play silence, like play zeros. Actually, that does mean play zeros, right? In our case, it doesn't mean play opus silence. Hmm. So the reason why I'm doing play opus silence is because when playing silence, I could just mem set the buffer to 0. Who cares? But the thing is, um, your speech might have been interrupted halfway through, and we don't want to go from there to pure silence. We want the transition. So that's why we're playing silence in this case through Opus, while starting, I believe, is starting is there we go. Monofield starting just mem sets to 0, right? So that's the difference. This guy mem sets to 0. While in this case we do the code missing. It would be nice to know when it's a good time to go from opus silence to back to proper silence. But for now, we don't have a methodology for that. So it's fine. Dread also needs something else. Dread needs sequence numbers. So with Dread, we need to know current sequence number and then the sequence number of the dread packet. Also, the dread packet has to be from the current restart. If it's from a different restart, it does not work. That's actually an optimization that you can do here. If sequence is different, no, okay, if it's different restart, then we do this. No, okay, so okay, up there we're good. Okay. Okay, now we need to improve our logic here. So if we're starting, we return starting. So far, so good. Nothing interesting. Then if we find our packet, if we find our boy, we're happy. That's nice. These and these are the parts that need to become more complicated. So we looked through the full buffer and only found all data, which means we're back to buffering mode. So return missing. Okay. And this is the case where we need to see if there's anything else. So we have a packet on our hand right now, but it's not the expected packet, and it is not all there. So we have a newer packet on hand. So the good news is that when we land here, we have a newer packet on hand already, so we don't have to search for it. The question is, does it have the same restart or does it have a future restart? That is important. So if okay, so here is packet loss, but we have a future packet on hand. Um, to perform read, the packet must be in the current restart. So it's next meta. Increase the sequence number, commit the read, um, and return missing. If it is um, if it is in the current restart, Then we increase the expected next sequence. We commit and we return. This is all good, but we need to prepare the dread stuff. Const. Oh, nice. IZLS. Yeah, this is going to be the dread case. So data is going to be, okay, these values are essentially these. The dread sequence is going to be next meta dot sequence. Info is going to be okay. Just call it dread. Not bad. I would say not bad. Not bad at all. Not bad at all. Okay, so with this, we are returning. I don't think I have broken anything. Almost. These should not commit. This cannot commit the dread packet. This needs to commit up to -1. Actually, do we need to commit anything? Wait, there's actually nothing to commit with this one because we're reading something future, but we're not consuming it. It has to stay there, so there's no R. There's no R to commit. This is the right commit that we need to do, and we're already doing it. So yeah, that doesn't need R. We only have we only commit when playing. That is actually cool. Okay, so I think we coded this. Now we need to change the audio side. Oof, boy, are we gonna need to change the audio side. Good thing that the math in this guy is trivial and there's no way I'm gonna ever get it wrong, and I never got it wrong ever in the past, and I never got puzzled for like a while looking at my thing and not understanding why I broke it. So man, good thing that this does not have these issues. So that being said, just in case, I'm gonna keep a copy of the old code around because you never know. Thank you, Dr. Teufel. See you. So we're getting buffer to play. If we have buffer to play, we play it. If we don't have buffer to play, then if it's starting, we play silence. If it's playing, this is not maybe playing anymore. Now playing has always the success case. So this is just playing, which means that these else case doesn't exist. And in here, the else case also doesn't exist. Okay. Then we have dread. And then we have missing. Missing is actually the stuff that I cut. So let me re-grab it. And this is missing. The difference is that I'm gonna have to look at the original code. In here, there's a .wang TLD. Nice. So I guess the value of having missing be playing with null. You know what? There was some convenience in having this integrated. No, I reject the convenience. If remaining len is greater than a packet sample count, then we're gonna do the code missing. Directly into voice read data. Voice read data is us. No, okay, so this is essentially the code for down here. It's the code up here that we're missing. Ooh, also, look at what bug we found. We need to commit the packet, even in the case of an error. That is kind of important. So if remaining, then the code missing directly in remaining. Then we moved forward remaining and we continued. Yeah. But in the other case, we would decode in our data. We would mem copy what was needed and then return. Yeah. Okay, missing is implemented now, in theory. All that we're missing is dread. For now, let's do it like this. Even if there is dread, let's treat it as missing. If we treat dread as missing, we should have a functionally equivalent client. If we can build. All right, jitter buffer cannot be empty anymore. Where do we do that? Oh, it's in jitter buffer itself. Do I understand correctly that you're trying to do an audio stream protocol over UDP? I am. I already have it. I'm now enhancing it with a. I already have it working with normal Opus, but I'm using a special Opus thing called Dread. And that's why I'm changing how the network interacts with the audio thread. So jitter buffer was used to do, what was it? Wait. We also need to init the thread decoder. Dude, oh my god, we need to do so much. So pub function init. So this is the thread decoder. Then packets cannot be empty anymore. Packets need to be initted. Okay. What other issues do we have? Oh, we have a playing equals null somewhere in jitter buffer. Uh-oh. Oh, that's bad. That means that there's a code path that I have not looked into. Where are we returning playing equals null? Is that, where is this stuff? Jitter buffer 185. Oh. They're missing. Okay. That was not so bad. Packets equals dot init. Where the fuck do you see this? Audio 101. Oh, wait. Okay. Yeah, no, that makes sense. Is there this type protocol where you don't think about security of the protocol? Since so far I see that you are only considering network issues. The way this stuff works is that your protocol doesn't care about security in on itself. Usually, what you do is that you wrap your protocol in TLS. I currently don't have any encryption because there are Zig blockers because I'm still developing it. So right now it's not something that I'm worrying about too much. But like I don't know, do you see much security Concerns in TCP? No, because TCP, like you just encrypt the data on TCP after the fact, right? So it's gonna here's gonna be the same. Like it's the same like with the HTTP versus HTTPS, right? HTTP and HTTPS are essentially the same thing. It's just that S it's a TLS wrapper around HTTP. Okay, what's the next problem that we have? Function with non-void return value implicitly returns. Oh no, expected U32 found U size. Also, why is CLS not helping? No, don't give me error access denied, motherfucker. Motherfucker, wait a second. Okay, so this is not lost. This is good. What about audio? Okay, so far so good. So we can close this. Okay, can I get ZLS help now? Oh, there we go. Actually, no. Incast my ass. This needs to be redefined. This needs to be U size. There we go. Okay, so far so good. What's the last problem? Error union type. Pass returns the info. Catch. Okay, that was a spurious error, I think. Oh, never mind. Error union, blah, blah, blah. Doesn't support field access. Oh. Oh, right. Yeah, what if it's full? Uh, what is it full? What do we do up here when it's full? Dropping audio packet, audio thread is too slow. Dropping audio packet, audio thread is too slow. And then we return. There we go. Expected type optional opus thread decoder. Yeah, it's fine, little dude. And it's also fine, little dude. Don't tell me. I think we're in business. That delay in solving that last error meant that we compiled. Okay, I'm gonna pause the music. I'm gonna turn on YouTube. If I hear myself back, it means that we haven't broken anything uh, with this integration. Keep keeping in mind that we have not yet enabled Thread. We just did some work to turn on Thread, but we're not leveraging it yet. So this is just a um, sanity check to see if we didn't break any of the logic. Or that could also happen. Invalid enum value. Ah, shit. So here's what happened. There are some new Opus errors that I don't have in my bindings, so I need to add those errors to my bindings. I updated Opus version, so I might need also to regenerate the C translated Opus headers. We'll see. And yeah, that also means that that Dread State Create failed somehow. How is this guy failing? How is this guy failing? Dread State is failing to create a Dread State. Why? Okay, let's go to Opus. That was I don't know what to think about it. I'm happy, maybe I'm not happy. Okay, let's take a look at the new Opus header. Um, where are the errors defined? Are they in here? Mm, defines? Oh no. Did we get a -7 unlock failure? No, I have unlock failure. Wait a second. What the fuck did I even get that back? 0, okay, all the way to -7. I'm flabbergasted. Yeah, you're right. I could switch on the original scene, but that's probably the better way of doing it. But also, what happened there? Two possibilities. One, uh, I'm just misusing the API and I'm not correctly looking at what it is doing. Two, uh, I package Opus wrong, and UB is coming through. Like weird ass UB is coming through. Opus thread alloc returns a thread pointer, takes in an error. Did I implement this correctly or did I fuck it up? I implemented it correctly. We call opus thread alloc. We do opus thread alloc, and that should return an error, and the error is bad. Or maybe they do it like this. Maybe what if it's this? We set it to 0, and maybe the way they've implemented it is that they forgot to write a value. They forgot to write 0 to the return to error in case of success. Maybe. Yeah. Maybe. Kinda. So here's my theory. My theory is that it's C. So they are assuming that the value, that the thing has already 0 in it, and they don't override 0. So if that is the case, then we don't have to do this. Then I need to double check if we can do echo of any kind. So I need an echo server. I do have an echo server. Uh-oh. We were not hearing anything. The fact that we were not hearing anything is not good. Their other functions do override the original value on success, though. Like if you look at my other usage of these APIs, I always set stuff to undefined, and I expect them to override them. Test. Okay. So we do have echo. Test. Test. Oh no. Oh no. This is not working well. Um so this is not echoing at all. Let's turn off the request for thread. Let's see if without thread enabled stuff kind of works. Maybe it turns out that you need to parse thread a little bit no matter what. Test. 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 Uh-oh. So something is a little bit broken. But here's the interesting thing. I have used this build of Opus. We tested it earlier. Like earlier today, I did test this and it was working. Hmm. And we are receiving data. We were definitely receiving data. Test. Yeah, we are receiving data. Um. Huh. Test, test, test. Test. Hmm. So let's see if the callback is called. I broke something. Good thing that we're doing this test right now. Test. Oh, okay. We're not printing playing. So we borked the logic, in our jitter buffer. That's good, I guess. Could have been worse. Okay. Jitter buffer. What is happening? How did I break it? State is starting. If you get to start count -1, if we get to start count, we switch to playing. Are we somehow never returning playing? So this code here can be ignored. This is not interesting. This doesn't do anything. It doesn't do control flow. It just collects stats. So that can be ignored. But we should be getting in here. There is no point in getting in here. In never getting in here. Hmm. Mm-mm-mm-mm. How did we break it this much? That is crazy. Test, 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 test. I'm not calling next or something. Like, what is going on? Next packet begin. Currency starts at 0. That's good. I I I broke it so much. Holy shit. Um oh, I think it's this maybe. No. No, I actually don't know. I'm gonna add some prints before. I'm gonna add some prints where control flow happens, and we're gonna take a look at what at where we stop. Oh, kind of weird. I'm really confused about how I broke this. There we go. What? I'm confused. Did I mess up the function name and now we're calling a default implementation? No, there's no way. Okay. We are entering the function. Congrats. Maybe you know what happens? We fail the check and then we end up down here. Are we always flowing down there? Is that what's happening? Test? No, we're not ending down here. Um, we're definitely not even entering in here. So that means that we are always getting in here or something. Okay, let's see what our packet slices length is. It's gonna be so stupid once I figure it out. It's gonna be so stupid. Buffer length 2. Uh, Buffer length 0. and there is a restart. Length 1, 1. There is something wrong with the way we do restarts, I think. Um, Star count is greater than 2. Yes, star count is 8. I think there's a mistake with how we do the writes, but we should never be doing a dread write, essentially. Um, like when in localhost, we should never do a dread write. So assert, well, you know what? If true unreachable. So we should never be attempting a dread write because locally we have perfect network conditions. We never have a missing packet. So we should never, never, never attempt. Okay. Buffer length is 4, 5, 6, 7, 7, 7. Okay. The, there is clearly there's clearly wrong math happening here. Clearly wrong math happening. I don't know how, but there is wrong math happening. Test, test. Yeah, so we never leave starting. It's not even missing. We're constantly starting. Okay. You're allergic to Zig? Test, test. Yeah, so audio is constantly starting. We have so yeah, we are like somehow throwing away packets that we should not be throwing away. So I think that this guy is fine. I don't think that this guy has the issue. I think it's the jitter buffer logic. Either that. Hmm. This I didn't touch this. I really did not touch this. Okay. At this point, I'm fairly sure that the problem is in here. There is one change that I did recently, which might be what's messing with us. So we did change write packet. Write packet does interact with this. It does write the first time the current restart and expect the next sequence. Yes. But only the first time. So this we turn off. We don't even consider it. Okay, so the bug must be in next packet begin somehow. I just don't understand. How is it that I fucked it up so much, even up here? Maybe I should look if I have deleted a line in here by mistake. But here we have the state transition. That makes us go down here, which we never go to, apparently. So I think I'll go have to I'll have to go to lunch first before I can fix this. I just don't know what the heck is going on. Buffer length equals 3. So does that mean that we sometimes enter here? Okay, I want to silence all the other prints. So no stats. What other prints do we have in here? No stats, no prints from you. Nothing to push. Buffer length equals 0. Buffer length equals 1, 2, 3. Stats restart. Buffer length equals 4. Okay. I think I understand what the problem is. The problem is it's not in the read function. It has to be in write packet. Oh, you know what? I'm an idiot. I'm a complete idiot. There we go. I think I might have solved it before lunch. That's kind of what we were missing. Test. There we go. Okay. It works. We have echo. That was so stupid. Took me way too long to get to what the problem was. In any case, that is good. That means that we have so far we have swapped in a new Opus implementation, and we have not regressed the normal case. We have added some more fancier logic to the jitter buffer, which is also great. Um, the next step is have the the audio thread leverage the dread case, and um, we need to get to a situation where we can experience packet loss. I have a button to experience packet loss, um, but we're gonna have to make it better. I think we're gonna have to add a new. We're gonna have to add a new button that says something like lose 3 packets every 5, for example, something like this. And or we need also to test this with our online server, which has natural packet loss. So I'll go to lunch and I'll be right back in 15 minutes. See you all in a bit. You're missing replay last and packets. You can do that, but I'm just gonna throw them away. Like, I have sequence number tracking, so if you give me all data, I'll just throw it in the trash. I'm not gonna play it by mistake. I'm back. Do. Let's see. What are we missing? I'm using Flow Editor now. Thanks for the inspiration. No problem. Does it have file folder view like classical IDE? It currently does not, but I heard from Neurosite that he's working on it. So the answer is it will soon have the preview. I don't think I'm going to use it. To me, that is vestigial stuff. Once you free yourself from any form of hierarchy, for you, it's just lines of code. And then you have in a sense, the current buffer is an extension of the model nature of your editor. And that's where it ends. That's where the hierarchy ends. Okay, so we were saying this works. Let's remove all the silly printing. Test. Okay, now we can go in audio and we can move playing and we can be happy. We're happy now. We need to implement Red now. So, how does this work? Whew. We know where we are. We know where the Dread packet is. So, const packets distance. Actually, the computation that I'm about to do should not be done by us. It should be done by the upper layer. Uh, okay. Packet distance is going to be Dread dot current sequence minus Dread dot. I should not call this Dread. I should call this. Oh well. Let's do Dread dot Dread. That's silly, but what can you do? Dot sequence. Okay, this is the packet distance. Now we know that this can only be, we can only do 1 second worth of this. So if packet distance times 2 is greater than opus Dread duration. So if there is, for example, because Dread has, I should write this down. Number of 10 millisecond mini frame, mini packets. Let's call them mini packets. They call them frames, but the frame is such an overloaded term. God damn it. So number of 10 millisecond mini packets. So these are 10 millisecond each. So if you are at a distance of 5 packets, those are 100. Well, 5 packets are 10 mini packets essentially. So if it's this, then it's missing. So that's why this code should go above. Yeah, actually, let's actually move this code above. So in jitter buffer, when we're about to return a thread, here we're gonna say we're gonna compute packet distance. Oh, we can actually. That means that we can write down the packet distance directly, so we can avoid this. Oh, that is actually good. So that we can do thread equals this. Oh, that is so nice. Thread n. Actually, we can copy this. It is fine. Okay, something like this. Okay, I think there's more stuff that needs to be fixed. Okay, distance is gonna be what we were expecting to find minus next meta dot sequence. Let's add an assert for an invariant. Next meta dot sequence is lower than next meta sequence. That's what we expect. Then we subtract if it's let's add a comment. We can thread only up to 1 second. Well, we can thread only up to 2 times Awebo opus thread duration. Uh, yeah, we can thread only up to opus thread duration divided by 2. Packets. So if we're past that, to say missing. Yes. Then if you go down here, there's going to be, whoops, we're going to have packet distance. I think this case should be called future, not red, I guess. Recovery, maybe. Distance in packets between the current packet and the current the future packet we're using for dread. Guaranteed to be within the dread window. Okay. The type of thread is this type. What are we gonna call it? It doesn't have a name. God damn it. So that is gonna be a playback packet string dot thread packet. No, wait. That part needs to be fixed. Did this all work out already? It did. Okay. Sounds good to me. Um, you know what though? I think we want to pass it down by pointer. We have no reason to copy all this stuff. Pass it down by pointer. Let's go. What could go wrong? Hmm. Okay. So now we have recovery. It is within red range. We literally just have to process the red stuff. So here's how processing red should work. Our buffer is empty. This is not optimal, but just to make it work, we pump in our buffer all the dread stuff that we have. All of it. just all of it. So and is going to be, so we're just doing this case. This optimization, I don't know when I'll do that. So this is going to be the minimum between how many samples we can take, which is going to be voice read.data .len, and we need to compute dread samples. Dread samples is going to be recovery.dread.info .end minus available, I think. Well, it's available times 10 milliseconds. That's going to be 480. That's the number of samples. Data. Oh shit! This needs to be a power of 2. So our data line is a power of 2, but we cannot use it all because we cannot use it all. Well, you know what? Okay, so here's how we do it. Let's not do mean. Let's just assert. Assert that data.len is greater than dread samples. We always try to write all the samples. Is it true though? Wait, because this is gonna be wait. We know how much this is gonna be. This is gonna be 1 second worth of data. Is our buffer gonna be big enough to hold 1 second of data? Do we want to write 1 full second of data? We do not want to write 1 full second of data. We definitely only want to write 20 milliseconds. We want to write a packet worth of data. Okay, so maybe this whole computation doesn't even matter. Let's do this. Assert that dread samples is greater than that recovery.dread.info.available is greater than for actually 2 or equal. Yeah, no computation needed. Okay, we assume that we have 20 milliseconds to write. So then we do it. So we do caller.decoder.decode dread float, dread state, dread offset, where 0 is the most recent 10 milliseconds. Oh my god, now I have to compute this fucking thing. So PCM is going to be voice read dot data slice from 0 to 4 to 960. Okay, we need to figure out red offset now. Um, we need to figure out red offset. So it's the distance times 2. I think it's just the distance times 2. I don't know. We'll see how this goes. Decoded float can return an error. Yeah, that's fair. Awebo's lander elsewhere on the internet. How? How can you see this lander anywhere? Like, how? That's how? Befredo? What? What did he do? Oh, oh, this also returns written. Never mind. Fuck. This is packet sample count. This is distance times packet sample count. What other constants do we have? Packet sample count. Okay, let's just leave 2 for now. Then I'll look into getting it fancier later on. Okay, let's see. hmm. Okay, we try to write from thread. We get how much we've written. We assert that we've written as much as we thought we were going to write. We assert that that's going to be enough to fill what we're missing, which should be, at least in my system. There might be systems where this is going to be. I might be required to make this better in the future, like more resilient. But for now, this is fine, at least on my machines. So then we do. We copy over. Boom, boom. Okay. And this is a return. In theory, this is it. In theory, this is it. I don't know. Maybe it works. Maybe we fucked it up. Only one way to know. YOLO. I mean, okay, technically this now is gonna work fine, but it's not gonna enter the dread code path ever because we don't have packet loss. So we're gonna need to induce packet loss. I have a button for it. I have a button. We can try and see how it goes. There's an assert. We hit the assert. Okay, that was expected. So let's go remove the assert in jitter buffer. So we are triggering the dread. We are triggering the dread code path. So this is the first hurdle that we need to survive. Will we correctly write dread data? Who knows? Test. Okay. Dropping media packet. Oh shit, we underflowed this. Oh, I'm an idiot. Of course, it's the new one minus the old one. Man, math. Man, math. Yeah. That's how you make the subtraction not underflow. Okay, next problem. Oh, we hit an unreachable. After the recovery, dread info available is greater or equal than 2. Well, god damn it, man. Okay, let me think about it for a second. So we parse the 0 out of thread info? How does it even work? Okay, so when we parse this thread info, let's write this data out. So we're parsing thread on arrival. So we're gonna write thread for sequence number this. Then we're gonna print also the info. So the sequence is gonna be sequence, and then info is gonna be dw.info.star. Okay, let's see what it is that we get out of thread. Oh, did I leave commented the thing that enables thread? Test. Oh. Well, we're totally getting 0, 0, 0. Please. Okay. If this is not what I think it is, I'm gonna be fucked because I have no idea what's gonna be causing this. Please. I have left the thing that enables thread commented out, and that's why we're not getting thread. Oh God, yes. Thank you. Oh my God. Okay. There's still hope. There's still hope. There is still hope. Test. Okay. Okay. Oh wait. There's one more thing. If we get 0, there is one more thing. Yeah, we're still getting zeros. Okay. Last thing. We need to go from application audio to application VoIP. Okay. Okay. Fuck. Uh, Why are we getting not read out of our stuff? Why, man? Why? What have I done wrong? What have I done wrong? What have I done wrong? Am I managing thread state in the wrong way? Is there like just one thread state that we need to share and it's not per packet? That would really surprise me though. But we can test this. So there is one place where we can observe all thread stuff. And we can do that unconditionally. Or maybe I need to do this. Maybe I need to do a signal request. I don't know. You know what? I'm gonna try this. If this, I don't think it will work, but who knows? If it doesn't work, which is what I would expect, well, then the next thing that I'm gonna do is um, test. Yeah. Okay, nothing has changed. So the thing that I'm gonna do is let's look at here at the encoder, right? Here we do encode. After we do encode, let's test this out. Let's see what it is that we did in terms of dread. Although, no, there's a better place for this. Let's go do it in network. In network, when we are about to send out our packets, we parse the dread information and we print it out. Media receiver, media sender. Because with that, we don't even need to simulate packet loss. We can just do that for every single packet. So every time media sender we receive a packet, if the bug is different than void, maybe we can even do it here. Then in debug, we put var dread decoder undefined dread state. Okay. Media receiver, media sender. Okay, so we create these two guys. And then, yeah, you know what? I think there is one dread state that needs to be like kind of permanent. I'm starting to think that there is a dread state that needs to be permanent. That would explain a lot if that were the case. Yeah, that explains why there's a process thing with two different dreads, but then why does the other one not work? Fuck. Okay, let's try to get it on the sender side. Get it right on the sender side. This is gonna be easier to experiment with. So then on here we do info equals debug dot decoder dot parse debug dot red state. Data is going to be, I think it's data. Processing is going to be the deferred. Okay, what is data? Read. Oh, just read. No. Read the data. Okay, there we go. Okay. There we go. Okay, with this, every time we send something with red, we should see it. And that we are gonna compute red also if we're not closing packets. And it's always 0, 0. Why? 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 We are sending out zeros. That is bad. So one shared red state, different ones. I don't know. Maybe matters. Maybe doesn't. It probably does matter. But it seems that we are like we're calling this function, and we should take a look again at the signature to see if we're doing it wrong. But so dread parse, dread decoder state, dread state, input payload, number of bytes in payload. Yeah. Are we doing it right? Yes. Maximum number of dread samples that may be needed if available in the packet. These could actually made better. You know what? These could be made so much better. Holy shit. Okay, that is probably a good performance improvement that we could make. So far, doesn't matter. Sampling rate. Sampling rate used for max dread samples argument need not match the actual sampling rate of the decoder, but it does. I don't think that putting a number too big there is a problem. Although 48,000 is not a lot. 48,000 is 480 is 10 milliseconds. What a weird way of communicating these numbers. I don't understand this interface. In any case, that's 100 milliseconds worth of stuff. But does it matter in our case? Not much. Doesn't matter much. Sampling rate, dread end, number of non-encoded silent samples between the dread timestamp and the last dread sample. Yes. For processing, doesn't matter. Zero if no dread present. So this seems to say that there is no dread present in the packet. So why is there no dread present in the packet? I don't know. Out of curiosity, what if I do this? If I set this to 101, I would expect this to fail. I expect it to be tripping an assertion on application startup. Please trip an assertion on application startup. Thank you. It does not. That's bad. That is bad. Um, Let's try this. In build a Zig, let's give Opus, where are we here? In GUI. Let's give up to Opus our optimization level. Let's see if this leaves some asserts in place. Also, I'm tempted to like enable UBSAN to see if that's what we're tripping or something. But why is there no assert on that setting? Come on, man. You should put an assert there. They tell you that there's up to 100. So why is this? I guess they're capping it automatically instead of returning an error. I guess it's time to go look at the implementation. Oh man, who knows now where's the dread stuff? So a bunch of it is in DNN. Dread encoder. Well, there you go. Load model. Use weights file. Enable queue next. I wonder where the config stuff is though. I guess it's still in the normal stuff. Needs to be before sale because of DTX. Okay. So what am I looking for here? Let's see. When we are in CWR mode, but we have non-silk data to encode, switch silk to VBR. Cap to save complexity. No, I'm looking for the setting to enable Dread in the encoder. Hmm. If that Dread experimental version maybe that is also what we need. Maybe that's also another def that we need. Dread experimental version. Let's take a look at where this stuff is in Opus. Mm, don't lie. Copy. Why are you lying? Why is RipGrep lying? Uh, is this not searching under the package? Wait, how does it work? How does this motherfucker work? Why is it not searching under the package? Oh, you put paths after. Okay, fine. So we have some if defs, and then we have a definition in dread config. So that header file is included. So that is not a problem with my build. That header file is when. Wait a second. Bro. Is it 10 or is it 12? Holy shit. Okay. What are my dependencies? Wait, are you saying? Are you saying that this has no, this doesn't have it. This has the definition to 12. Who is it that has the definition to 10 then? Okay. I have some garbage in here. Okay, that's what's going on. Okay, I have some garbage in here. Um, I have garbage, so that's what's going on. I have a copy of an older. Yeah, I have a copy of an older version of Opus that I was using before, and so that's why I was getting conflicting values. Okay. So we're good. We're good. So Dread experimental version is defined. There we go. Opus set Dread duration request. Okay, yeah. They're oh no, go to bed arg. Go to bed arg. What is Dread max frames? 4 times dread max latents. What is dread max latents? 26. 26 times 4. Oh, okay. 26 times 4 is 100 and change. 104. Okay, so the reason why we are not getting any, we're not tripping an assert is because I was within that margin of error. So if we go to 105, now you trip the assertion. Please trip the assertion or return an error. There we go. Thank fucking God. Opus bad argument. Thank you. Okay. So not all hope is lost. Some stuff still makes sense. That means that we can go to 104 if we want to get extra spicy. You know what? Fuck it. 104. Why not? Okay, we were somewhere in here. We lost track of that, but that's fine. So we are turning on dread. Why are we getting no dread? Here's how I would do it then. This is also 40-50. Let's double check these matches. Is this 40-50? I should stop searching code on GitHub. It's garbage. $40.50. Okay, so that also works. So we're happy. Opus demo. There we go, friend. We're gonna be best friends. Hello? Oh, it's nice, right? I forgot. Bitrate, bandwidth, VBR, complexity, in-band FEC, force channels, set DTX, set packet loss percentage. Look ahead. Maybe we need to set packet loss percentage to something that is non-zero. Maybe this guy defaults to 0, and that's what's causing issues. If packet loss is 0, what do I even put thread in it, right? Get look ahead, LSB depth, set expert frame duration. Set force mode silk only. Oh shit. That might be something that we need to do. That might be something that we need to do. Okay, let's try. Actually, we need to look at this in the headers because we don't know what that thing is supposed to be, like how you're supposed to express that percentage. Why do they make the interface a fucking macro, man? Will automatically switch to silk even at high rates to enable use of that fact. Yeah, I think. Okay, you know what? I think the more than packet loss, I would say. Okay, I'm gonna comment this out. I think the more than packet loss, we want to force silk. Oh shit! It's not even defined because when we translated that macro. This is bad. We didn't have the definitions. I think so. Maybe actually we do have them no matter what. Let's see. Force. Oh, application restricted silk. Oh, I guess we can do that. Opus application restricted silk. Um. Oh no, we don't have it. Do we? Fuck. Well, it's 2052. Fuck it. 2052. Are you happy now? I don't know if this does what we want, but we can try. Oh, you know why Ripgraph was not searching in Zig package? It's because it's in my git ignore. It wasn't searching in the git ignore directory. Now I get it. That makes sense. Okay. 2052. Not changing much. Or not enough. I don't know. Okay, let's leave it application YP. Let's do the packet loss then. Oh, it's an integer. Percentage in the range 0 100. Inclusive default 0. Okay. So it's not float. So let's do at c int 50. 50% packet loss. What are you gonna do? You're gonna crash. Okay. 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 The decoder parse gave us trouble now. Let's go. That seems good. This also needs to be set to 0. This is doing the thing again. We now have triggered the logic, and now it's not touching the variable anymore. It's leaving it uninitialized, uh, which is annoying, but fine. It is not leaving it uninitialized. It's writing something to it, and we don't know what it writes. Well, fuck. Okay, let's change check error to be less shit. So no enum anymore. We return switch error. Okay, this is so much better now. Wait, we do have STD. So what's your deal, dude? So we triggered the logic and we got an error. Man, if the number is gonna be just garbage, I don't know. That number was not garbage. This number does not look like garbage. This number looks good. I might be misusing the API. Oh yeah, because that is a number where the number needs to be negative. The numbers are all negative. This is a positive number, so that is the problem. So if r greater than 0, return. All the error numbers are negative. So this is what's happening because um because we did with this thing we checked the error in available. Okay. I think we're in business. I think we're in business. Test. Yep. Oh my god. Holy shit. Not bad. We have it. Okay, now we need to change this to be um, sample rate. I mean, 48K is actually correct, isn't it? Let me think about it for a second. If the sample rate is 48,000 frames per second, so then what we obtain is Then we obtain kinda 48,000 available frames, isn't it? But at around 20,000, we start having starting this. What the heck is going on in there? Okay, I want to try this again. Test, 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 test. This is me talking. This is me talking. This is me talking. A B C D E F G blah 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 blah. I don't understand those numbers. Oh shit. Like while talking, it buffers 20,000 samples, more or less. Does it always buffer 20,000 samples? Also, why is it 20,000? Why does it buffer always 20,000 samples? Why is it this? And then there is silence. Silence is not necessarily me. Oh, wait, no, it might be a sequence restart. A, B, C, blah, 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 blah. No. Yeah, there is a restart. Let's read again what is available supposed to be. Offset positive of the first decoded dread samples. Zero if no dread is present. Offset of the first decoded dread samples. So it's an offset in time? It is probably an offset in time. That explains why it hovers at around 20,000. No, it doesn't. Wait. That doesn't answer it. I mean, 20,000 does kind of smell like 20 milliseconds. But at 48K sampling, 20 milliseconds is 960. So what the fuck is this number? $20. I don't know. Oh no, what is that number? 880. Like it says, like I hate these fucking docs because they say offset so nonchalantly. But like, is that what kind of fucking offset are we talking about? Offset positive. dread offset, position of the redundancy to the code in samples. Oh, okay. So these are numbers of samples. Offset positive of the first decoded dread samples. Offset positive of the first decoded dread sample. 0 if no dread is present. Does that mean that it is the oldest, the newest? Position of the redundancy to the code in samples before the beginning of the real audio data in the packet. So the way I understand it is that like 0 means that we are at that. So we want to do, I guess we want a fixed number, right? We want that dread offset to be, no, it's not fixed because we don't know, because there is a distance. There's the concept of a distance. So it's not just distance times 2. It's distance is packets, and we want to turn that in samples. Okay, let's see if this is it. Okay, this is going to be, I don't know, exciting, a disaster, I don't know. We'll see. So I'm gonna press the magic button now, and we're gonna see what happens. Test. Uh, uh, we're not doing it right. Wow. Wow. Yeah. Yeah, we're definitely not doing it right. -1. No, that's, wait, what the fuck am I doing? I mean, actually, wherever the -1 goes doesn't matter. Is this minus end? But we can test this with end set to 0, so we're getting close though. We just need to figure out how to use these values at the end. This is actually pretty exciting. Meow 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 meow. Meow 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 meow. Meow meow meow. Meow 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 meow. Nope. So it's not a core distance -1. Actually, I think this is worse. What if it is +1? Blah 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 blah. Blah 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 blah. No. What if it's this? And then it's this. Available minus that stuff. That's a problem. Uh, no, no. That's not it either. I don't know. Distance -1. I'm gonna try a few different combinations. I don't know how to use this value. You know what we're gonna do next? We're gonna have to look into the Opus demo code that we kind of were looking at some point, and we're gonna need to use that to see how to proceed. Blah 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 blah. Blah blah blah. God, these results are worse and worse. Okay, so far the best thing has been this. So far, this is the best one. 960 frames times the distance. We're asking Opus to keep around 100 of those things. Hmm. Dread unlock. No, come on, man. There cannot be no other mention of Dread in this file. Oh, there we go. Set DNN blob. If you wait, fine. What we're not doing. Dread input. Oh, I think. Oh, we're getting deliciously close. Oh my god. Opus get last packet duration. Opus get last packet duration, but we know this. Well, in our case, I get it that some people might be doing weird stuff, but in our case, our one packet is 960. That doesn't change. Thread input is lost count times output samples. Yeah, this is the computation that we're doing as well. This is the computation that we're doing as well. Okay. Although this is being used here, that's That's not that interesting. Oh, what if we were supposed to do plus instead of minus? You know what? Can I undo? Can I redo? No, I can't redo. But here I did available minus this. What if it was plus? That seems weird to me. But what if it was plus? I think this should be going down. 0 should be essentially the present, and then it goes back in time. It shouldn't. I expect a crash. What? What? Also, I shouldn't stay silent. I should keep talking for a while and then blah, blah, blah. I can tell. I cannot. I straight up cannot tell. I mean, it's not right, but I don't know. Maybe one of the ones that I tried is the right one, and it's just doing its best, and it's just too hard with what I'm doing. I am doing weird noises. Maybe I should be talking. I should be enunciating a word. I don't know. Figure out how to trigger the decoder when the last packet of the file is lost. Oh, fix me. Okay, that's fine. Let's see. Get the last packet duration. Opus. Dread. If FR for real. No. What the fuck is frame? Lower than run decoder. Run decoder plus equals lost count. Here's the math. Lost count minus, I think, where we're at times output samples. Lost count minus, so that's okay. That is literally our computation. This is the delta between us and that packet times number of samples. So this was it. This is it. Oh wait, though. Wait. This is calling dread decode, though. No, it's right. Opus decoder, dread decode. Yes, no, it's not the. Too many things are called dread, have dread decode in their name. But no, yeah. So this is it. So either I'm miscomputing distance, or I don't know. Let's print distance. If I'm not, I mean, to be clear, a 5-packet drop, like 5 packets missing in a row, that's kind of traumatic. That is 100 milliseconds. One. There is 100 milliseconds worth of data that is gone, and then this guy has to come up with. So that is a lot, to be fair. Um, Abana banana, ababana banana, abana banana banana banana, arbana banana banana. Huh. You know what? We need to try it online. Real world condition. Let's see what happens. Test. Okay. This is we with myself. And occasional dread. Oh. It's not perfect. Oh my god. Why is it fucking up at the end of everything? That's bad. Why? Why? No. Okay. This is a bug that I've introduced. There is something wrong going on. Test. Okay. What the fuck was happening? Oh. I'm starting to think that there is a bug that I've introduced. Like, what the fuck is going on here? Okay, here's my theory. My theory is that I don't need to have a bajillion dread states flying around. I think I need only one. Let's test this. Only one of these guys, not a bajillion different ones. Or maybe one for how do we do it? Let me think. Like, the truth is that here we don't even need to do any dread thing in here. Well, maybe for convenience, you could argue. So let's not do eager. Let's do deferred, and then on the reader side, we're just gonna have one. We're just gonna have a special one. temp dread. Uh, do you plan to add support for multiple codecs? Codecs. The one I've sent in the web channel is really awesome for low bitrate audio. Um, I'm not against this stuff. I would just say I would like first the basic stuff to work right. But the idea of having channels where you set in the channel different levels of quality and you have very high quality and very low quality, I would be fine with that. I definitely want to support that. And if very low quality means switching away from Opus to something else, I would be fine with that too. I would be interested not only in codecs that are they don't use a lot of bandwidth, but also codecs that are like particularly lightweight, with the idea that they work also on embedded devices. For example, Opus has a fixed point version where you can run it on hardware that doesn't have a floating point coprocessor. Well, FPU. So that would be interesting for sure. What were we doing? All right, we were trying to have this guy here when we're here, and we're about to dread for serious. They're sending audio over LoRa. Oh wow, yeah, that would be cool. Honestly, having LoRa devices be able to use Awebo, that would be so fucking funny. uh, so we want to do dread dot info equals info equals. No, we don't do anything to info. We just do um oh, we need a decoder, but I guess we can use that other decoder. Can we use the other decoder? You know what? Let's not fuck up the test just because we were stingy with decoders. State source dread dot state. Actually, this is more like a crash. This is a catch unreachable. And this guy is going to be jb.temp dread. Okay. And the final thing is that we need to pass the other state here. Temp state equals jb.temp thread. Or actually, I mean, we have a pointer to the JIT buffer. Let's use that. For us, it's called caller.packet. Okay. Let's try this locally and see if it kind of works or blows up everything up, and then we try remotely. Test. Okay. Jesus. Okay. Let's try the remote one. Test. Test. Banana. Oh my god. It's so broken now. Why? Why is it so broken? It's like I broke the decoder. Either that. It has to be the decoder that is broken because I cannot imagine this being. Hello? Oh, no, you know what? Wait. In any case, there's still the network in the middle. So let me try this without the network in the middle. Test. Banana. No, even locally. We kind of break the decoder. Why? Why is it like this? Hmm. I don't know. Is this designed? Is this designed to go with forward error correction, and then without forward error correction is janky? I don't get it. I think I'm misusing it, but I don't know enough. But you know what we can do? At least we can look at this thing. What is the dread state that we're passing around? Is it always the same? Yeah, look at this. So here's dread. Come on, man, go to definition. This son of a bitch doesn't even know how to go to definition on dread. Man. So it's just one dread state that gets used over and 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 over again. So that means that we want to have one dread state. We want for sure to have one dread state that belongs to the sender, one dread state that belongs to the reader, and then we kind of flip them around. Although I don't know. I think there's no point in us doing any early processing. Like, why do we even care? We don't even care about doing any dread processing. I mean, sorry, pre-processing. What even is the point? So let's change this. There is one dread decoder and one dread state. They both belong to the reader side. Here we just do normal writes like before. Don't care about this. Don't care about any of this. Let's resume printing stats because that's nice. No tramp dead. Actually, this is a dread state. There you go. Packets doesn't need an init anymore because uh, we're not storing the dread information at all. Maybe one day we'll do it again, but for now we don't. Also, why is this so corrupted? No need for an init then. Just an init. Right begin, right commit. I'm gonna keep them around commented because you never know for a rainy day. But we're not gonna use them. Then we don't grab dread. Parse. Catch an error. If there is an error, return that missing. And this can actually go in here. Thread is going to be .info equals this. State equals actually there's not even a point. Yeah, there's not even a point in having something nested because it's going to be the info that we have in here. And then the dread state you will grab from the jitter buffer directly. There's no point in passing it down here every single time. So temp decoder parser jb dot dread state. Actually, wait. What are the arguments for parse? I forget. State data processing. Okay, so we were right with this. Data. And then eager. And we can call this thread. Okay. There you go. Goes back to being just a normal init. Goes back to being thread. Thread state. Okay. And I think jitter buffer still has a problem because this guy was calling. Oh, this guy has an init again. But it's fine because it needs to have these guys here now. Okay. Uh, this thread stuff is kind of sucky. I don't know if I'm doing something wrong when using it though. Test, test, test. So well and good. Oh, I'm gonna try to drop less than 5 packets. Let's see what happens. Only one packet dropping. Ah, okay. And now it's gonna start to suck. Why? Why does it suck? It's almost as if I'm. It kind of plays the same thing twice at the end, right? Why? Why does it do that? And the thing is, it has to do with how we call opus silence on missing. Like it kind of breaks opus silence. Yeah, I don't get it. Maybe it's the. I don't know what the fuck. I genuinely do not know what the fuck. Also, we should do the computation on parse data here, not just the distance. So we have the packet distance, and that is great. But then we need to do it like this. Okay, data info, and then we do if info dot available is lower than packet distance times again. What if it was -1? I have this weird feeling that we should at least subtract 1. Anyway, this times Awebo opus packet sample count log dot info or debug. Um, thread has no packet available for dread, but it has no data. Not enough data. I think we need to also have a condition for uh, being in end. Enough available and the end stuff. I don't remember. Between the dead timestamp and the last thread sample. The thread timestamp and the last thread sample. I want to see. Okay, I want to see the demo code use end. Now watch these motherfuckers never use end and just not give a flying fuck. Where's the dread parse? Dread parse. Dread end. Where's dread end? Dread end. Okay. Dread end is not. Oh, you know what the problem is? Oh my god, you know what it is that I'm doing? Here's another thing that I'm doing. Oh, I'm not transmitting data, but I'm not enabling DTX. What if we need to enable DTX for it to behave correctly? I don't know. The problem is also that we are not enabling DTX, but we're not also not doing it the way they want us to. So I don't know. Test, 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 test. Uh, uh. Okay, it's fucked up. Why? I don't get why it fucks up our Opus decode. And you know what? It's actually our Opus silence. We can test this just to be safe. In when missing, let's do it like this. And down here we do, or you know what? Even better. Temporarily comment it out. And let's deal with missing as if we were starting. Period. Okay, if I do this, now Dread is not gonna fuck up my end of sentences. What is introducing that echo? I am running the server in echo mode. So when I connect to the server sends back my own voice. When testing it locally, it's just so that we can test the full. It's kind of like an integration test. But when running it with a remote server, then you now have realistic packet loss and network weirdness in the mix, and you can test a real world condition. So test. Banana. You know what? Maybe we should not use the code missing from Opus. Just write silence. Yeah, you know what? I'll take it. Just say put silence. Fuck it. It actually sounds fine. Maybe it's not gonna sound as fine with a worse microphone. Let me try this. Actually, not from here. Test. Blah. Okay. Awebo did not survive this transformation. I hate Apple. Test. Ugh. Horrible. But also fine. I mean, yeah. It's fine. Yeah. You know what? Writing zero. Writing zero wins over Opus the code missing. Fuck it. Mem set for life. Now, oh, this is interesting. I expected Mute to work a little bit better than this. I think that the application is still listening to us and then just not sending the packets to the server. Probably Mute can be implemented in a better way, but still, this is fine. Yeah. Okay. Cool. Oh, but here's what we didn't test. We didn't test what happens with packet loss. So okay. What happens now with packet loss? So it's normal. We're gonna skip 5 packets. It kind of sucks. Yeah, it really kind of sucks. Not doing a particularly good job. I don't know. Banana. Let's see. Okay, let's look. Let's look at what happens here, the history. So we drop 1, 2, 3, 4, 5 packets. On the other end, there's a bunch of issues with packets. Distance equals 5. 4, 3, 2, 1. Okay, let's mute the outbound thread because we don't care. So network. let's comment that out. And let's look at everything again from scratch, but without that spam. Uh, uh, drop packets. Late 66. 66 was late? Was it really late? Was it really late? It's not late. It's 100 it's 100 milliseconds after this one, but it is 6 it's 5 packets afterwards. No, I guess it's I guess maybe we are late with that one. So we because we dropped 61, 62, 63, 64, 65, and then there's 66. Okay. And these are 100 milliseconds worth of packets. So this one is arriving. I mean, why do we think that these guys are late? Because this is wrong. Okay, this computation is wrong. I'm definitely fucking this computation up for sure. In any case, we're gonna be at distance 5, 4, 3, 2, 1. Hmm. Although to be fair, it no, that makes sense. We see this. Okay, let's take a look at the jitter buffer. Well, ultimately, that's code that prints stats, so it's not that important, I guess, everything particularly right, but we print late if the packet is not at sequence number +1. Oh, okay, I see the problem. The problem is that this guy, once this guy goes out of sync, nothing puts it back into sync. Like, this guy doesn't have knowledge of what exactly is like, the current sequence number. Yeah, this whole thing is wrong. Okay, you know what? I'm just gonna remove the late marker. Late doesn't mean shit. We don't know how to compute that. But for computing the time difference, we need to do this. There we go. Now we're good. Yeah, the local sequence tracker is, I don't know, silly, not useful at all. Uh, test. This is interesting. On on a packet loss, it seemed that the jitter started going up, and it wasn't recovering. I'm gonna try to lose 5 packets again, and let's see what happens to the jitter. So so until I interrupted my voice, the jitter computation went up when doing this. This is weird. Why did the packet jitter go up? Because I don't think this packet jitter really went up. What's causing this artifact? Like, this is fine, right? This is correctly computing the correct jitter between my packets, which is not much. Then we lose some, but the sequence numbers continue, and then we're still aligned clockwise, but then things go out of whack. Maybe things really go out of whack. Is it because of the dread stuff? Out of curiosity, what happens if I turn dread off in Opus? Let's see what happens now. So this does nothing. Let's see what happens now. Still though, kind of weird. Yeah. Yeah. That's kind of it. Okay. Holy shit. We're stuck. Packet available for red, but it has not enough data. Yes. And what are we doing about it? We're forgetting to do this. That's, by the way, a very problematic thing. Did I have this bug also before? Could this have been the source of my issues before? Well, I guess we can test it. Jesus. Oh, I was too fast. No, why is this janky? Okay. Test. There we go. Banana. Hmm. I don't think this bug was affecting audio playback before. But in the spirit of trying everything, let's uncomment this. Although I don't think that was the case, but the way that the glitch sounded, it might have been. Why is the server causing me this pain now? Come on, man. Let's go. Okay. Banana. Honestly, better than nothing. To be fair, there is something of value in in the way of the coding. Okay, let's turn this on. Oh, you know what I'm fucking up? One thing that we've seen everybody else do well that I've been fucking up is that I have been coding these numbers here. Oh my god, I should not have been coding these numbers. But now I can avoid coding them. Okay. Samples. I think I might have found the thing that was fucking us up with Dread. Holy shit. Okay, I have not fixed it. Wait, this is not gonna compile. Right. Okay. We need to compute. How much stuff do we need? Always this fucking number. It's gonna be packet instance distance times. We need these many samples. If only we could put this into a constant, huh? Uh, you know what? We're gonna not do that anymore. Packet distance, sample distance. Do 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 do. Do 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 do. Do do do. Do do do. Yeah. No. Okay. We're not doing great. We're definitely not doing great. Oh man. Let's look at the demo code again. So the parsing is not happening in a loop. The parsing is correctly saying, give me the minimum between sampling rate, maximum between 0 and red input, which is loss count times output samples. Yeah. Loss count times output samples. And then the minimum between that and the sampling rate. Red input is red greater than 0. Oh, red input gets basically clipped to what the value that this thing returns. And this is saying if the current packet that we're in is the last, and we have the previous packet loss concealment, then we play it this way. Otherwise, also with the code data, otherwise, with the code, if thread input is greater than 0, yeah. I need to understand well these competition here. This fucking FR. So I think FR is our current packet. It's our current sequence number. And we're saying if our current sequence number FR starts at 0, this whole logic is so weird. I don't understand why they structure it this way. Like, I get the general gist. I'm just not 100% confident. So if this is the, yeah, so if this is the previous packet is missing, so the packet that you have in hand is the sequence plus 1. This is this is current being next packet plus 1. Okay. So this is next to the sequence minus current packet. Okay, this is last sequence. This is this. We have this. It's this bad boy. Yeah. Clanker is not gonna fix it. Clanker is gonna fuck up all this shit. No. Clanker doesn't do a good job with this stuff. I tried. I did get some help out of it, but Clanker not good. Monkey better than Clanker. So it's better if I do these things myself. Yeah, then it's this. It's the subtraction multiplied by packet sample count. And that's what this example is asking this guy. So for example, if we are, although, you know that these structure like this, kinda a little bit makes me want to do this. It kind of makes me want to do this. I don't think this is gonna solve it, but I can't believe I wasn't looking at Vim. Yeah, it's that's the flow control tagline. I can't believe it's not Vim. No, I'm joking, but So, oof, test. Don't do -1 skid. Don't do -1 skids. Oh, we tripped the assertion. Well, I mean, that is actually fine. Let me silence this for now. Okay. Uh, yeah. God damn it. It starts with this thing at the end. I don't know. I just don't know. Hmm. Uh, this we might as well change it so that we can we since we have this number, might as well send it down. I think we should rename this also. Yeah. So every time I try to make a change to this thing, I don't know, something always is a little bit more fucked up. What's the problemo? There's a log debug. Oh, what? Okay, give it a distance in samples. Maybe there's something sus happens with that computation, but I don't think so. How are we gonna fuck it up? Uh, uh, dropping. Oh, wait a second. Wait a second. Packet available for Dread, but it has not enough data. We needed 4,800 samples, and it had 4,560. Wait a second. Interesting. Why? Why did it have only these few? Then we tried again and again. Is the UI the easiest option for a GUI application? I don't know how to answer that question in the absolute sense. I don't think I know what is the absolute sense easiest option for a GUI application. If you're using Zig, it is definitely one of the easier options. If it's not the easiest options, is one of the easiest options. If you're just want to make a GUI application and you don't know Zig, there might be easier ways, depending what you already know. But within Zig, it's fine. And, there's also Raylib, what's it called, EMGUI, the usual suspects. I think that what happened here makes sense, but also like I think it's telling, but I don't know. I don't know what to do about it. Okay, let's try again. Banana, 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 banana. That sucked. So that sucked. But you know what? I think we're getting there. I think we are getting there. I think we're getting. I think we're getting there. Also, let's print something when we are actually. Oh, okay. When we print this, we are using red. Okay, when we print distance, we are using red. So here we're trying to use a packet for red, but we think it doesn't have available what we need. Then we succeed at using it. Then we fail again. In samples before the beginning of the real audio data in the packet. Okay, I think we need to reason about this number. So we are at a given point in time, and there's a distance between us and them. And we need to say how many samples before the beginning we are. Okay, so the idea is that we're going. So for example, if the very next packet is missing, then this should be 20 milliseconds. If one packet is missing, we need 960 samples. If only one packet is missing, we need 960 samples. 960 samples. Does this number need to be negative? Okay, let me try this. Now I'm actually curious. Okay, I'm gonna drop one packet. Test. Okay, I'm going to drop one packet, and I expect distance to be 960. Banana. Dropping me a packet 0. Packet available for dread, but it has not enough data needed. 960 and had 720. That number cannot be samples. That number just cannot be samples. It just cannot be samples. Also, is the demo using that value? How is the demo using it? So when we do Opus Dread parse, we set dread input to red, and then we don't use it again. Holy shit. Wait a second. Only the code, the amount we need to fill in the gap. Dread input. Okay, so the number returned by dread parse is thrown into the absolute garbage. We have dread n that also gets thrown into the garbage. And then here, all we care about is call dread the code. We just call dread the code. Okay, what if we didn't care about this? True or something else? Oh, am I a fucking idiot? This is not enough available. Not enough. Okay, let's call it not enough. Yeah. Okay. Not enough. So that never triggers. So we always go into dread now. YOLO. Uh, uh, I'm an idiot. Uh, uh, okay. Banana. Why am I seeing this? Wait a second. Why the fuck am I seeing this? Oh, getting owned by my own stupid thing. Uh, I'm just me up. Ah, okay, delightful. So we got all the shitty behavior. Distance 960. And we did ask 960 things to the other guy. I don't know. Is that position of the redundancy to the code in samples? Before the beginning of real audio data in the packet. Is the offset something you need to add? Do we need to sum the offset? No, that's what we're passing in. Of the first decoded red samples. Maybe we do need to do this. What if that's what it was all along? Are we happy now? We better be. Yeah. Test. Banana. Huh? So, okay, so we got the end that is fucked up again, but test. This seems better. I think this sounds better. This does sound better to me. I think we are now finally decoding the right stuff. Test. Okay, I think we're finally decoding the right stuff, but we there's still the end of speech artifact that I don't get, but let's try it online. So this is online. Let's see what happens now. There's gonna be real packet loss, maybe at some point, I guess. Conceptually, what layer of abstraction are you integrating Red at? Why doesn't the Outpost library handle it for you? Dread is part of the Opus library. It's a special kind of encoder and decoder. The reason why I need to do work to integrate it is because it needs to integrate. You need to use it in a smart way. It needs to integrate with the jitter buffer because it's basically, think of it as long range redundancy. So basically when you have Dread enabled, every single packet, every single data packet contains 1 second worth of redundancy. So that means that when you basically have a packet loss, you can grab any future packet that you might happen to be available, as long as it's not more than 1 second into the future, and then you can ask it to provide you with frames that come from any of the packet that we're missing in the middle. So let's say that your playhead is here. This is current audio thread playhead. These packets are all missing. You're about to play it, like you're done playing packets that you did have. You're now about to start playing a packet that is missing, and there's like 3, 4, 5 packets missing. Then you can, let's say that there are 4 packets missing. If you happen to have the 5th available, or any future packet available, and if that distance is not more than 1 second in terms of playtime, then you use this packet and you say, okay, give me this many samples from that far into the past. To be able to do this computation, you need integration with the jitter buffer. Then, but this part I've already done. This part is done. It's actually maybe not exactly trivial, but it's not that complicated. The problem that I'm having now is that there is no documentation on how to use this thing. The docs are the doc comments on the header files suck. They call everything a fucking offset. You have no idea if they mean bytes, samples, frames, time offset. Basically, the comments are not meant to be docs. They're just saying, I think they're essentially saying that we're not going to bother with proper documentation until this stuff is standardized, because the Opus Thread is not yet standardized. So I guess it's me trying to use a thing that is still in development. So I'm trying to learn how to use it, and I think I figured out the semantics of some of this stuff only now. But there's artifacts. So now you can see. Oh, it stopped. Oh, no, this one is fine. Okay, so here I'm using a remote server, and so far I have not experienced packet loss. We have not been using Dread, and so far it's so good. But when testing locally and when causing packet loss on purpose, we were basically left with some weird state in the decoder, because every end of sentence where the silence begins would have weird behavior. Test. So far, not even a single usage of Dread. That is crazy. So this is me connecting to a remote server. And the server is not that great. So actually packet loss should happen from time to time. That being said, if I'm muted, I'm not sending data. I'm not sending audio data. There we go. Here it happened. We got packet 16, 17, 18, 19, 20, 21, 22. Oh, wait, what? Expected 14, found 12. Okay, so what the fuck? We lost 13 and we got 12 twice. So this is how the network works. So we dropped 12 again, 12 into the trash. Okay, so now we did play Dread once, and now my decoder is fucked up. Yeah. Blah, blah. Why? Hmm. I don't know. So this is a partial success. It would be nice if this was, 1000% working, but it's not. Um, Actually, let me hear again the local situation. Actually, is there a delay node? Because I would be curious. I would be kind of curious to delay my input more. How do you do this? I guess you do it with by adding another buffer somewhere. Oh, here's how we increase the latency. Wait, I actually know how. Go to jitter buffer 64 60. There you go. 60 packets worth of buffer now. So there's just so that I can have more delay in my voice and I can listen what happens uh, to playback when I introduce packet loss. Ooh, although what is five what is dropping 5 packets going to do though? No, it should work. Okay, it's fine. Okay. 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 Ooh. Okay. Holy shit. Ooh. Yeah. Yeah. Holy shit. Yeah. Yeah. Okay, there's a lot of delay. Okay, there's a lot of delay. Banana, 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 banana. It's not particularly good. Really. It's not particularly good. Really. Uh did we end up using dread? Blah blah dread. Yeah. Ah. Ah. Yeah. I don't think it's even that. I don't think it's even that. This is not it either. I really don't know. I don't know what available means. I mean, I did call it available, but maybe that is the wrong name. Offset positive of the first recorded that thread samples. Zero if no thread is present. So offset positive of the first recorded thread sample. Like like in what sense offset? Is in that we cannot ask you for stuff that is within the time range? Why do they not have any form of documentation, man? God damn it. Also, why does their demo not have any real usage? It just like super fucking um shitty and unrealistic. Hmm. Oh, here's how it works. Holy shit, I also learned how you use forward error correction. Jesus. I learned how to do this. Okay. Um, Here we're just checking that red input is greater than 0. We're not checking any of the other stuff. There's also like end, for example. Number of non-encoded silence samples between the dread timestamp and the last dread sample. Yeah, I look at that code base, but it's C++ and it integrates with WebRTC, so it's all fucked up. The truth is probably out there. You're right. I looked at it a little bit. Actually, if you want to do if you want to go spelunking, please be my guest. Um, but yeah, so far I don't know. I guess I could clone this and just search for Dread. You know what? I will admit I did use GitHub. I did browse it through GitHub. That's a bad move. Let's clone this bad boy. I mean, it's only C++, right? What? How bad could it be? I'm gonna get T. I think I'm gonna need T. Okay. It's only C++. It cannot hurt you. You can modify this file to create no-op change lists. Try to write something funny, and please don't add training white space. Once upon a time, there was an elephant in Stockholm. Why did the elephant get kicked out of the Swedish parliament? Because it kept making drunk calls. Okay. Discard redundant extensions. Remove mutually exclusive extensions with lower priority. Oh no, Dread. Oh no. Second red payload type. Oh no. Cricket. Okay, Opus interface. Well, we're gonna get there. M place back. To do cling m at amazon.com. Eliminate this copy with a shared read-only buffer. I, I have no idea what the fuck I'm reading. I have no idea what is going on. Holy shit. Thread end. Oh, there we go. So this is just a little bit below. Okay, thread end. Copy on write buffer. Thread parse. Samps. If samps is greater than 0, thread end lower than samps, then samps is subtracted thread end. Then why are we getting these two numbers separate if then you're supposed to just subtract them? Find the desired number of 10 millisecond chunks. Have we all along operated in 10 milliseconds chunk for real? And then so because they do say elsewhere that they talk about things in terms of 10 millisecond chunks, but then the docs say samples. When we look at this thing here, this is talking samples. This is talking samples. This guy is assigning. So this operation returns sample numbers. No, that's not the point. The question is whether these thread functions. So there is one thread setting that accepts a number expressed in 10 millisecond chunks. Then these other functions instead don't operate in that sense. Those other functions seem to operate in individual samples. And this is what this code is also doing. This code is 100% confirming. Also, wait a second. Wait a second. Output samples is 0. We write to why I hate also this programming, this C style programming, man. Not as bad as the C++ one, but holy shit. So we start output samples to 0. We write to it last packet duration. I'm gonna go look into it, but I would assume that this tells us how many samples were decoded the last time that the decoder was invoked. Oh yeah, look, also every loop we reset it to 0. Okay, so then sometimes we assign something to it. Oh, wait a second. So when we get into thread input, we do thread input, and then this greater than 0. Stop output samples equals dot in minus dot out. Okay, I think this is stuff for the demo, for demo purposes. Dot samples, output samples. Okay. See, this other stuff is just for the purpose of the demo. Okay. So my question is, if that guy is talking in terms of samples, why are we back to talking in terms of chunks of 10 milliseconds here? So let's see. Thread count is samples. divided by the sample rate times 100. So let's say that red parse gives us 960, or even simpler, it gives us 480, 10 milliseconds. It gives us 480 divided by 48k times 100. Okay, what does this? Okay, I'm curious to see what this calculation would return. Times 100. Also, we're missing zero. Oh, wait a second. Am I missing a zero? Am I missing a zero somewhere? No, but just so for okay. Okay, so they return 0.1 times 100. That's 10. I don't get this computation. Desired red count. What's going on here? What is going on? Auto P new opus frame. Unique pointer encoded audio frame P. This whole thing smells like garbage. Check out the wrapper function. What's the wrapper function? Is this the wrapper function? I don't know how to read C++. R. WebRTC opus decode red. Well, I guess we'll get to that in a moment. There's red parse. Oh, but that's what we were looking at. Decode red. Go to definition, sends me to web space RTC. Namespace RTC. I mean WebRTC. I guess it could be worse. You can't even go to definition in this fucking language. It's worse than JavaScript. Oh, to be fair, I should be measuring how big these packets are. You know, I'm I should be measuring this. How do you get a little split window at the bottom? It comes with the editor. I'm using flow control. It's just part of the editor. Yeah, let's assert that we. Oh, I killed the server. Let's assert that we do stay in that window. Because obviously, if we have like crappy writes, then that is indeed a problem. Although I don't think that's gonna be the case. Yeah. Okay. A function that encodes the right information cached in the decoder into a 10-millisecond slice of audio. What if if this is really um that? What if this is really the number of things in 10-millisecond increments? Um, I don't think that is the case, but let's say that it is. So we have the distance in samples. Then we want to divide these samples by Awebo dot. You divide by the frequency. So again, let's say that we have let's say that you have 480 samples of distance divided by the frequency 0.1, and yeah, not only you can sorry, I'm answering this. Not only you can do that, but you can also like whenever you search or you have LSP errors, they will show up down there. So and then you can do Control J to close it. So that will give us 0.1. Actually, no, it should give us 0.01, right? times 100, and that gives us 1. Okay, if this is correct, we can avoid doing all this stupid math. They're doing offset times sample rate divided by 100. Well, I guess they're doing this because this is probably not bad. If you do it like this, fuck it, I'm gonna leave it like this. But I guess the other way around is what allows you to, it maybe guarantees that this part here stays like gets simplified, like it gets computed at compile time. I actually don't fucking know. Anyway, test. Oh right. Test. I added a super delay. Let's reduce the super delay to something normal. Test. 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 No. No. It's still fucked up. Banana. No. No. It still produces fucked up audio. My suspicion is that the reason why we end up with a decoder that produces garbage whenever we end a sentence is related to the fact that we're not feeding it the right number here. I think we're like messing it up because of this. I don't know. You know what? Maybe it's dread.info.available plus this. I don't know. I'm trying all the options. I have no fucking clue. Uh, banana. That didn't sound bad. Banana. Never mind. Yeah, I just don't know, man. Okay, let's go back to the WebRTC code reading. What a pile of trash, man. Set duration. Set complexity 5. Should we do set complexity 5? Why are they doing set complexity 5? What is default complexity? They're doing this adjustment, but you know what? I don't trust them to be doing this stuff correctly, so I'm not gonna try to replicate. decode dread samples, inst, sample rate hertz divided by 100. Decoder, dread decode. Oh, there we go. We finally we're starting to get to the C bindings. So here we're starting to see how things actually are. Reinterpret cast. Offset times dread samples. They are genuinely doing the 10 millisecond stuff. Yeah, but you know what? You know what? Here's my suspicion. Okay, when is the last commit in this curse repo? So this is stuck to 2 years ago. I bet you that if we now go in Opus and we go back to 2 years ago, 15.2, is that 2 years ago enough? That is 2 years ago enough. Wait, update dread readme. There's a dread readme. Oh, it's just for development. Okay, from this, now watch the signature of these things be different. Oh no, nothing has changed. What if we go to 0.15.0? Maybe they did change something afterwards. Oh no. They still talk about samples. So sample rate hertz divided by 100. No, wait. But wait. That is correct though. Wait. Because they are so um they are multiplying. They are multiplying whatever number you pass in by let's say that so the sample rate is 48k, right? So if the sample rate is 48k, then this becomes 480. So they are multiplying whatever number gets passed in by 480. So the number passed in is the number of 10 millisecond things. 480 is the 10 millisecond thing. So they are operating in samples. Okay. So they are doing this is even more hilarious. They are doing the 10 millisecond mambo jumbo everywhere, and then at the end they turn it back to samples. So they are doing all the initial transformations for no reason, and then they're coming back to samples at the end to interoperate with the C API. Okay. Dread parse. Note, processing not deferred. That's fine. Okay, the final thing that we need is the dread decode on the decoder. Where's the dread decode on the native decoder? Multi-stream decode. Decoder create. Opus decoder create. Decode native. Opus decode. Decode PLC. Opus decode. Decode FAC. Oh wait. That's I was already looking at it. Okay. They also seem to be completely ignoring no, maybe that becomes part of the initial computation, right? So the code that we were seeing before, they subtract end to available samples. That is so weird, though. I think we saw everything that there was to see here. So this is like this. Hmm. What if the lagging is because it's taking too long? You know what? What if the lagging is because it's taking too long? We should test this hypothesis. Although that doesn't explain why sometimes it's this. Okay, I'm gonna print here the info though. Packet available for Dread, but it has not enough data. Needed 960, had 720. But I do think we're starting to get bullshitted a little bit because it cannot have 720. It cannot just have 720. Actually, maybe it can. Is 720 a multiple of 2.5? It is. No. But even then, shouldn't we be get wait. Wait. Should we not be getting these things in 10 millisecond chunks? No, we've been told that it has to be a multiple of 2.5. So no, everything is a multiple of 2.5. I want to see the dread info though of everything. Even I want to see the dread info of this as well. Oh, could it be that we're doing it wrong here? Wait a second. What if this becomes 48K? Test. Uh, uh, so here's the story. So here's the story. We were passing down a number that was too low because we see that available is a lot more. Out of curiosity, what if we put here 480? I bet you that if we put there 480, then it's always gonna say 480. Oh, I was too fast. Test, test. Uh, banana. Hmm. Hmm. Let's see. Test. Test, test, test. Test, 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 test. Hmm. And it's always 0, which does make sense. Number starts low when we're just getting started and then goes up. 19,920. But I mean, I guess it makes sense. So that means that it contains 41 chunks of 10 milliseconds, 4 chunks of 100 milliseconds. So it contains 400 milliseconds of data. But I'm asking for more than this. I'm asking for a full second. Maybe the problem is that I'm not setting the some stuff the way I should. One could be complexity, one could be bit rate. I'm not setting the bit rate. Maybe what we set in the packet loss percentage has a meaning. What if we put 80% instead of 50%? What will that do? Test. Oh, too fast. Test. Test. It has changed nothing. Okay, let's now, when actually needed, let's print also, no, not in here, in jitter buffer. When actually needed for real, I think the needed is distance samples plus 1. I think that this distance is correct, but then here we need to do plus 1 because it makes sense, right? To cover that, we're gonna need more samples, like one packet more worth more samples. Maybe, I don't know. Maybe this is it, but we still produce garbage, even if we put 48K in there. Uh, uh, Needed 960, available 720. So dude, why are you lying? Why are you lying? So let's do this. Let's do this on samples plus Awebo, Opus, packet, sample, count. We add another packet worth of samples to the list of samples that we claim we need. Okay, so that did do something. Where is it? Where did my packet loss come into play? There we go. Used thread needed 960, available to 640. Okay, here's another thing that we know. Given that this number changes based on what we say initially, this is fine. so, so we did use this information, but it still produced garbage. Test. Uh, banana. Yeah. Okay, what if this, the +1 thing, should actually be in here? So we should the same number that we use here should be used on the other side as well. That would make a lot of sense. We just need to use it twice. Banana. There. Banana. Why? Uh, so in conclusion, that +1 seems kind of necessary, because otherwise Opus is gonna lie to us about its ability to fill in, but then we still end up with a corrupted decoder. Maybe the decoder that we use for Dread should be a different one. But no, because these guys use the same decoder for everything. Doesn't matter. So they don't do that. Um, Here's the question: do they have doc comments in the C implementation? Maybe that could help, but I think we're reaching the end of this adventure. Oh no, Flow, why are you like this? Oh no. Ouch. So what we want is Opus decoder, dread decode. Right. I need to add randomness, yeah. Sure. Well, look, I can make a branch and push it now. Well, it's up. Opus Dread Coder. Hmm. Okay. Look at the. We're back to the sampling rate math. 100 times max dread samples. Yes, dude. Divided by sampling rate. So offset here is expressed in 10 millisecond windows, right? Am I getting this right? Max dread samples. We don't know what max dread samples is, unfortunately, because it gets passed in. Oh no, we do pass it in. That's the value that we pass in. Okay, so it's in samples. So let's say that we say 480 divided by sampling rate times 100. We say 480 divided by 480 is 0.01 times 100, 1. So offset is measured in 10 millisecond windows. Awesome. Then it's just not used anymore. Oh no, it's just defined in here. Wait, are we really not using it anymore? Oh no, it's used here. Minimum feature frames. Offset. +2. Minimum between offset +2 and 2 times dread number redundancy frames. Okay. So they actually do add, 20 milliseconds to your number. Unless this has some other meaning. But in any case, EC the code. If not the for processing, Opus thread process. We should probably take a look also at that. So these should take the processing stage to 1, I think, or something. Let's see. If thread end. Oh, so you can even decide to not pass thread end. It's the maximum between 0 and minus thread offsets times sampling rate 400. Okay. And we return the maximum between 0 and thread end. What the fuck? This number already subtracts thread end when we return it. So it's already subtracted in the implementation. If payload is different than null. If payload is null, thread end gets set to 0 and we return 0. Okay. So that means that the subtraction is not necessary. Thread end is meaningless. Well, and then we continue. Thread process. Decode all. Process stage, okay. Let's take a look at thread parse. 1 second, just in terms of what we do with thread. We set process stage to -1. I think we're essentially resetting it. I need to look at EC the code. Next. It's not in here. Of course it's not in here. Why would he be in here, right? Why would he be in here? Dread EC the code. It is in, no, that's the call. Oh, wait. Oh no, Helix has the same problem. We are inside. Oh no, so stupid. Um, This is the code. Opus Dread is now what we were calling Dread State now is the decoder. It's the decoder for Dread stuff. What does that mean? It means that it's kind of stateful, but no, we're resetting its state. Let's take a look at what we do with it in here. We just assign to it. State. Latents. That above sets latents, whatever. Okay. Process stage. Deck state. Deck state. Okay, I think that um I think that this is fine. Like the usage that we're making of these decoders right now, it's fine. I think this is it. I don't know what else to do other than maybe ask for help in the Opus issue tracker, I guess. I don't know. I think this is it. Like we did do the work. We did do all the work. But we need to keep Dread disabled because it just doesn't perform well. The good news is that we can also add forward error coding. So, the good news is that looking at all this stuff, I learned how to make forward error encoding work. So we can do that one. Oh, you know what? Maybe that is really what is missing. Like the fact that we're getting hit and miss behavior in the middle, it's disappointing. Obviously, I would like that thing to work nicely, and it's clearly not working nicely. Share your ghosty config. Dude, it's default config. It's the default everything essentially. I I'm using as a theme IU Dark. That is sorry, IU Mirage. That is the only AYU Mirage. That's the only personalization. And it's not even no, it is a ghosty personalization, but that's it. Yeah, no, like at some point you kind of outgrow the age where you're, busy touching your configs all the time. At some point you realize that your hands can be used also to try and do useful stuff. Um, that's it. So that's why my stuff is. Also, software has improved over time, I guess. How are you getting around the title bar? Oh, well, about that. I wish I didn't. If you ask me, I wish I didn't have rounded title bars. That's because it's macOS. The new macOS renders title bars this way by default. I don't like it. This whole new macOS UI sucks. 360 degrees, but I don't know. That's what I'm getting. So long story short, it's not even me. Blah blah blah. Blah 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 blah. Horrible. Absolutely horrible. Yeah, this is nothing. Yeah. To be fair, not all software is getting better. That's for sure. Some is, some isn't. But for example, things that needed configuration in the past, like I don't know, text editors, like Flow has different configuration out of the box. Ghosty has a different configuration out of the box, so you don't need to mess with them too much. Um, I think I'm going to comment these things out, and then just merge everything into main branch. Yeah, I just have no idea why this guy is like this. The good news though is that, you know what, before committing, let's introduce also forward error correction. I think that one is going to be good. So in jitter buffer, playing what are return types? If FAC is true, then the um you know what? I really hate having to do this way. FAC. Actually, this is not even playing because we are not committing the read. Um, I think we'll have, it's a lot of copy paste, but it's better to copy paste than do something else, I guess. No, commit. No, commit. No, commit. I hate this so much. You know what? Pack is, it's literally the same thing as the other one. It's designed to be the same thing as the other one. Let's do the fact thing here. We pass in plain.fact, and then here we do if. Actually, no, you know what? We call packet commit, and then in packet commit we say if playing.fact return. Yeah. Yeah, there you go. Man, it's literally a two-line change once you do it right. Holy shit. There you go. No more fact. Put fact in here. Down here. Fact equals false. Then when we do into dread stuff, if the instance is only one, there you go. The next thing that remains to do is in Opus, we need to enable this. Let's see how it goes. Test. Okay. So far, so good. Banana. Banana, banana, banana. Hmm. Hmm. What? Holy shit. Banana. Okay, if I do this, in theory, um, shut up, Obsidian. Okay, test. Let's see. Uh, 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 uh. Oh, we fuck it up. Here's my drop packet. Here's my drop packet. Dropping out the packet of the thread is too slow. It means that we're looping. Oh wait, am I missing some like return condition somewhere? But I mean, oh yeah, definitely there's a bug. We forgot to do this. Every time we have a return point, we need to do this. Man, I might as well just do this defer almost, but no, it's not a good idea. Okay, so uh, found the error. Found the error. Test. Test. Yeah. Okay, this is without FAQ. Can you check if you're returning an error in the fur? What do you mean an error in the fur? Oh, no. The fur used to be able to catch error values, but it can't anymore. So it's unfortunate. I'll go to Opus, re-enable this. So now we should be able to use FAQ for the occasional packet loss. Test. Yeah. Listen packets 1 using FAQ. We did. Everything is beautiful. Test. So we were able to use FAQ and it did not fuck up our ability to use the tool. So for example, now I'm going to connect to the remote server. Now I'm connected to the remote server and There you go. Here, let's see what happened here. Package jitter, package jitter. Why are we using red? What is happening here? Distance packets equals true. First, we try to use red, but since I didn't enable it, there's not enough data. So we play silence. Then distance packet becomes 1, we use FAC. And then we continue. So far, so good. Yeah. This all works. This is all working correctly. Test. Banana. Again, lost 2 packets. Try to use red, didn't work out. Then used FAC. So far so good. Let's re-enable Dread. And now watch it cause havoc. Complete havoc. Test. Banana. Okay. Let's wait for a natural. There we go. It happened. We lost 2 packets. Used FAC. Used Dread for 1 packet. Didn't even fucking work out. We needed 2,880. Why do we need 2,880? We were 2 packets behind, right? Oh, distance packets is 2. Oh, no, wait. There is one thing to say. We are reanalyzing the same packet multiple times, and that is a bad idea. Oh, you know what? This might be a problem. We were analyzing them only once originally when we were doing the work in the receiver thread. And now here we are actually not doing that. I think we need to have around a Boolean that says whether the packet, I think we need to cache. So we need to cache this information. So on the reader side, so we do need to have a place where to store the FAQ information, and we need a Boolean that says whether we have already parsed it. Or even better, we don't just ask 20 milliseconds. We ask all the space. Yeah, we ask for all the space. Although that is not what the sample code does, because the sample code does keep invoking this guy with decreasing values, which is what we are doing. The problem is that we are also repeating this. Okay, there is space for one more improvement then. Let's go to jitter buffer, and we're gonna re-add back dread. And in dread, what are we gonna put? Just info. What are we gonna put in there? We put an I32, I think. We splat it to -1. Then we go to we splat it to -1. Then when we are in here and we compute info, we do this. If jb.packets.read at n is different than -1, we use it. Let's just call it available. Oh, I think there's a better way of doing this. There we go. If it's not initialized, we initialize it. Otherwise, we grab that value And then we do the not enough computation. Okay. So this way we don't recompute stuff needlessly, which might have been the problem or part of the problem. I don't know. And in any case, it was wasteful. And then in here in commit or in write, commit or write, commit or write. Let's do it in commit. Oh, but this is so cute. No, let's do it in write. Um, set red to -1. Okay. What's the problem next? Why do you even care about this at this point? You don't even care about this anymore, it seems. Okay, now I'm curious. Now we don't do weird competitions multiple times. Banana, blah, blah, blah. Blah, 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 blah. Okay, one packet we use fact. Easy. Let's try 5 packets. What happens with 5 packets? Oh. Oh. Wait. What? It is fucked up though. You can hear. Wait. Yeah, it is fucked up. Oh well. Test. Banana. Why is it fucked up in the middle now? There even isn't packet loss. What? Dude, come on. Why? Oh. No. Test. But did you notice that we don't have the horrible breakages? Oh my god, we don't have the horrible breakages from before? Wait. We don't have the horrible breakages from before. Now watch me fix this +1. Or maybe it's not fixing the +1. Maybe that's not the answer. Maybe we need to adjust it a little bit. But I think we're finally getting close. This is actually sounding right. Test. Banana. Okay. Fact. Easy. Multiple packets. Okay. No more shit. It worked. It is working. Holy shit. It's almost working. It's lying to us because it doesn't want to give it to us, but then it works. So here's how it works. Apparently, I think that there's a bug in their implementation. I think they need to adjust this manually. I cannot believe it, but it seems that we're in business. Like, it seems that we're truly in business. This shit is all on, right? Yeah, everything is on. Holy shit. I think we're in business. Test. Banana. Fuck. We're back to everything being shit. Fuck. Wait. This is I don't know if better or worse. Test. Meh. Yeah, now it's kind of corrupted. So we're experiencing another kind of breakage that I don't understand. But we are getting there. We are getting there. Comments for bug hacks, fixes? You mean what the Opus people should fix? I don't know. I'm barely starting to understand this thing. Test. Oh. Wait. Is this okay? No. Audio now is corrupted. Why? God damn it. Yeah. We are like so close. We're so close. The thing is, though, it doesn't. Let's try this. Wait a second. Let's try this. Come on, man. Test. Yes. Okay. Banana. This doesn't corrupt. This doesn't corrupt. This doesn't corrupt, but occasionally it will say that it doesn't have space for us. But it seems that it is lying. So let's say that not enough is false, and so let's turn off the not enough. Let's ask the thing to give us stuff, even if it says that it doesn't. So instead of increasing artificially how much we're asking, let's just ignore that value, because that's what they seem to be doing everywhere else. So let's see what happens now. Banana. No, we are corrupting the thing. So this is the right solution. The right solution is to listen to what it says and not use it when it doesn't say that it can. Okay, with this setting, is it working correctly now? It will sometimes not kick in, even though I would expect it to be able to kick in. But test. It doesn't corrupt anymore. Now it works fine. This is the intended usage. Okay, let's use it online with the real world. With real world like packet loss. Test. Banana. Oh no. Now, watch it not lose a single packet. Okay, there is way too much spam. Let's remove some spam because it's spamming way too much. So let's stop spamming the dread info every single frame in here. But that's what we're doing here. Stats, packet jitter. We can keep packet jitter maybe. That is fine. What a tour de force. But this is how you use it, it seems, in the end. Holy shit. Holy shit. Wow. 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 Banana. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh no. Oh no. No. Again. No. Dude. Please. Why? Uh. Why? Why did it fuck itself up again? Test. Uh, now again. Negative jitter. Yeah, negative. Well, yes. You can have negative jitter. You expected something to arrive at time X and it arrives at time X minus 1 millisecond. That can happen. So it seems that it works fine in the local test case. Here locally. Banana. No. It did not work at all. Oh no. Why was it working fine though before? It seemed to be working fine for a moment, but then not anymore. No, the debug statement, the logging stuff. Oh, you know though what? You're right that this guy. Wait a second. This guy does have unintended side effects. Wait a second. You're right. That thing does have unintended side effects. Test. Test. What the fuck? Oh wait, I think it was weird at the end. I think it was a bit corrupted at the end. Let's try the online one. Test. This is with the remote server. Banana. banana, nana, banana, nana, banana, banana, banana. Oh my god, are we not losing packets at all? Really? Well, I guess I'll have to do it myself. Uh, 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 uh. You're fucking right. You are totally fucking right. What does that mean, though? Oh, okay. So here's what that means. This is parsing thread info every single packet. Down here, we're only parsing that info occasionally. Could it be that we are supposed to parse every single packet no matter what? Because this is literally what this is doing. Like the only thing that this is doing is making sure to parse thread stuff for every packet. Although this will also parse stuff multiple times. So I don't know about that. Okay, let's do it this way then. Let's assume that this is the case. Then that means that this needs to be moved here. This is going to be data. There is no distance samples that we know of, so we're going to go with 48. Okay. If there's an error parsing, we do nothing. So this is more like this. Is this somehow what makes it work? Test. Test. Banana, 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 banana. Fuck. How? Why? We're using it wrong again. Oh, wait. This should be the third. This thing is so fragile. Test. Okay. Yeah. It works. So you have to parse every single thread. So that means that we can turn off forward error correction. because personally I don't love it. So we turn it off. We go in jitter buffer, and we turn off the FEC stuff. Actually, let's put it as a configurable setting. Let's try it without FEC. Because FEC adds extra delay, and I don't think I want that. Fast. Yeah. Banana. Yay. It works. Oh my god. This is amazing. Holy shit. What a fucking adventure, man. What a fucking adventure. So it turns out that you need to parse every single packet. Was it obvious from this thing? Yes. This was parsing every single packet. So you have one state that you keep around and only one state that does this parsing. Also, they have the prepared thing that uses two different parsers. Because that means that you can have the like non-critical parsing happen, I guess, in the receiver thread. The problem is that if you might do that, but then you're not gonna be able to use that thing, I think. Like, I wonder how they expect you to use this. But yeah, it works. Holy shit, it works. It works. I can drop. Yeah. And it works. It just works. It's amazing, actually. Like, I'm dropping 5 packets at a time. Like I'm spamming. I'm spam clicking this button, and it kind of works. Yeah. Not perfect, but I mean, 5 packet drops at a time. It's not nothing. Holy shit. Success. This is a success. I can't believe it. We finally got something that works. Jesus Christ. I was losing so much with the Apple audio stuff. Finally back to some winning. Okay, so with this, we can change this stuff. And this is pretty much we're close to state of the art of packet loss concealment, essentially. Well, actually, no, we are at the state of the art of packet loss concealment, probably. But most importantly, we are close to the state of the art of how this whole thing works. There are 2 things that we don't do right now. One, we're not adjusting dynamically the buffer level, but I've done the preparation work to enable it. I just want to get this stuff done first and play with it for a while and then attempt the next dangerous thing. And the second thing is packet request to resend a packet. Now, this last one would be actually pretty cool The problem with it is that it only makes sense if you're very close to the server. And I don't know how to estimate. I don't know how to estimate how close we are to the server. I guess I guess we could provide a timestamp, and then the server, whenever it sends us packets, it provides us with another timestamp that we can use to evaluate distance between us and the server in terms of milliseconds. But I don't even know if resending packets is really worth it. So far I would say so good. Holy shit. What a fucking adventure, man. Um Crazy. To be honest, we could keep it on and just lower it on the other end stuff. You know what? Let's do this. We turn it on, and then we go in jitter, and we lower this to 5. I mean, we have so much good shit going on. Fuck it. Let's YOLO it. 5. And let's see what happens with with 5 packets. Um Oh my god. We figured it out. Holy shit. We figured it out. Man. So this has been an 8 hours, 8 hour long stream filled with pain, but I emerged victorious in the end. Holy shit. Now let me try with the reduced delay how things are with the remote server. Because now we have reduced this delay, so we are like much more subject to packet loss. Well, not much more, but more than originally. So let's see. Where's my packet loss? Expected 21, found 20. Oh, why is restart 105? I'm confused about restart being 105. That being said, I don't print them, so do they somehow survive the server? No, they don't. This restart is way too high. In any case, um, so we expected 21, but we found a 20. Okay, so we had a duplicate. Okay, there we go. Decent packets equals 1. So here we lost a packet. We did concealment. Nice. Wow, what a mess. What a mess with those packets sometimes. Okay, what the fuck is going on with these restarts? This is. I really think these are flipped around. No, this is a sequence packet. Why is restart 5000? Okay, let me see about this. Remote user. Holy shit. Wait a second. Wait a second. Who put this garbage in here? Motherfucking Opus. It's shitting its stuff all over the place. I can't believe it. Test. Opus! Oh my fucking god, man. Yeah. So I think it's on me. I think I've enabled something that I should not have enabled in my build script. I think it's this that we probably don't need to enable. Maybe it's either that or maybe OSC as well. I don't know. Unfortunately, I looking at their build script, it's unclear. It's unclear what you're supposed to do. Start the build again without that flag. We're recompiling libopus because we changed the build settings. Test. There we go. It's not spamming anymore. Beta Zig needs merge. Bro, why are you so fucking annoying? Okay, what is going on? I'm confused. Beta Zig? Oh, yeah, you see, we need to get pull. Already up to date. Okay, I have not merged my own PR. Okay, that is the problem. That explains it. There we go. Okay, then. Remove this. Remove this. Okay, so there's a problem now because we're failing CI apparently. maybe we're failing to build. We didn't do any cross-platform change, but maybe we're failing to build Opus for Windows. I don't know why I'm accusing Windows, but that's usually the culprit. In any case, we might be failing to cross-compile Opus. Yeah, we are failing to cross-compile Opus. No. Oh, it's the tests. I haven't updated the tests. That's on me. Okay, let's finish this so that we can really check that cross compilation is not broken. Okay. So we can just do Zig build test and watch it fail there. Yeah, one more tab. After all, why not? Jitter buffer line 457. Jitter buffer.init. Next question. That was it. And now we pass CI. No, we don't. Expected for arguments found 3. Right. It's because we were supposed to pass IO. Is there a testing IO? There's IO and IO instance. Well, anyway. And whenever we call write packet, we should do the same. Now that's the only place that we'll call write packet. Are we happy now? Next, playing or else. Um, mm, error parsing dry, opus invalid packet. Yeah, about that. That's a problem now because I have to comment this out because I need to get rid of this test because it doesn't work anymore. So that's fine. Okay, I think we have fixed the eye with this. There we go. Happy again. Holy cow. What an adventure. What an adventure. Success. Um, with this, it's straight up success, period. It worked. So, well, what can we say? I don't know. I don't know. I think your Firefox is having a stroke. Video is fine. In OBS, it's fine. I have also a stream preview window that it's fine also there. So that's on you. Make sure that you have Thread set up correctly in your Firefox. Yeah, Firefox is losing it too. Yeah, Firefox has lost it a long time ago. Well, I think this is it. Thank you all for hanging out. We won today. I hope you had a good time. Today we actually did win. For real, no joke. We won. So there we go. So I think I'm gonna call it a day. I'll see you all next time. I'm gonna have a victory